If you're in school, you're taught that this is what the solar system looks like. There's that bright thing in the middle, and then there's the planets that orbit around, and there's emptiness in between. We live in a living universe. We will not understand anything. We won't even know what we're looking at if we think we're looking at a dead thing. No mainstream astrophysicists predicted anything like this. However, electric universe theorists were like, oh, you're going to see filaments. The center of the galaxy is so energetic, it is so hot there that none of that should exist. What do we find? We find filaments. And so that's part of the electric universe paradigm, is that stars are shining because they are digesting galactic energy. There's been a scientific conception of time, which is that it is something that just flows forward. Older knowledge taught that time has different dimensions. We're going to follow through the electric sun model in a laboratory, and we're going to see if we can replicate some of the behavior of the sun. Every living thing is emitting light.
Welcome, Michael Clarage.
Thank you.
In our podcast, we have two comments that are very, very consistent comments. And one has to do with my hair. And everybody's always commenting on my hair. And the other has to do with Michael Clarage. When are you going to get Michael Clarage on?
Oh, wow.
So this is like the perfect way to cover both topics. I spiked my hair today. We're talking about the electric universe. So I am completely spiked out with electricity today.
It's great.
And pumped up and ready to talk about this thing, man.
It's so exciting. It's so great.
Yeah,
I'm looking forward to it.
It's going to be awesome. It's going to be awesome. And this is like kind of with how many times I've heard your name requested as a guest for this show, I would have figured you had done dozens of big time podcasts, but this is kind of like one of your first big ones, right?
Yeah. I am totally seeing this as the beginning of a new phase.
Love it. Very cool. Very cool. Well, this is the first time, it's the beginning of a new phase for me because it's the first time that I've done my hair like this. And it's the first time that I've ever discussed the electric universe on the podcast. So this is going to be a big learning experience for me and I think for the audience. We're excited to learn from you today.
Yeah, awesome.
So your quest today is to be as convincing as possible using, facts and data to try and convince the audience that this is a real legitimate possibility, probability, a reality that we live in. Yeah. So with that intro, why don't you go ahead and tell us a little bit about yourself and maybe start with, what is the electric universe?
Sure. A little bit about myself. I primarily am at home in academia and research. I keep coming back to that. Having said that, I think I've worked 6 other jobs, careers that are not that. So I also love throwing myself into entirely other things,
Cool.
Yeah. And so right now I'm going to talk primarily about the scientific research side.
Great. Yeah, I'm looking forward to it. And so what got you interested in this topic?
Yeah, so this was 2012 or 2011. I had left academia at that point because I was just fed up with it, and we can talk more about that. And but I couldn't stop researching, and I was preparing some lectures on supernovas to give privately in Boston. I would rent a hall and get 100 people in there and talk about something. And so this one was supernovas, which are stars that they transform into something else. We don't really know what supernovas are. There's a lot of theories about them, but they primarily are a kind of like a caterpillar to butterfly jump for a star. So it's part of a star's design, just like it's part of a caterpillar design to take that jump. Does that mean every star takes that jump? No more than it would mean every caterpillar takes that jump, right? So supernovas are these incredible things. I was doing research on that, and I stumbled on this one guy, Wal Thornhill, who said that, it's primarily an electrical phenomena. And I was just like, what does that even mean? Because I was raised in traditional astrophysics, right? All you need is gravity and nuclear power. That's it. Everything else, you know. And so started reading his article, and then I just left it, gave my presentation in Boston on supernovas, and then came back to it. I was like, what was he talking about? And then went back to it, and I read it, and I saw his arguments in his articles, and I was like, holy cow, I think this guy's right. And then I reached out to, I forget who I reached out to, and that started this very rapid snowball of me entering into this. It's called the Electric Universe community. And I went to the conference, the first conference, like 9 months after that, just to see, are these people nuts, or is there some serious science here, right? And I was so impressed with the level of intelligence and care and thoughtfulness there. There was plenty of people who were nuts, as you would find anywhere, but it wasn't like the movement was nuts. It was like, you know, and so then the next year I gave my first presentation to the group on my understanding what's going on, and that really just exploded. And what's great about the Electric Universe community, it is not a solidified paradigm. It is in the sense of we, the scientific community, has so underestimated the role of electricity everywhere. We've underestimated the role of electricity in the human body, in the atmosphere, in the sun, in the galaxy, like in geology, across the board. We have completely underestimated. So that's really the only paradigm. And within that, there's lots of people like me researching, and generally we're pretty tolerant of each other. It's like, you know, I don't agree with what you just said, but go, you know, do more experiments. It's not like, you know, sometimes people will ask me, well, is there an electric universe view of whatever? And I'm just like, that's the wrong way to ask the question. You know, I have my view on it. I am not the electric universe, you know.
Who is the guy? I know I've heard of Thornhill, right? He's one of the main characters.
It's a great history. You can trace it back. There's always been people, scientists, who have been studying the electrical aspects of everything. And they've generally just not gone anywhere, not much traction. So Wal Thornhill was set on his journey by Immanuel Velikovsky. Do you know Immanuel Velikovsky?
I do, yeah.
So everyone should...
But for the audience.
This Russian polymath who wrote this book where the premise was, let's assume that people who wrote things in the past were not just making it up.
Seems reasonable.
Exactly, right?
Yep.
And his focus was on history and cosmology. And he kind of reopened that question of cataclysms. Like, there have been cataclysms that have happened on the Earth that have completely reset things. And that the age of humanity is, who knows? Who knows how long the humans have been on this planet, right? But these enormous cataclysms are real things. It really did happen. You know, across the globe, there will be stories of, this was the time when fire rained down from the sky, where we all had to hide, where the orbit of the Earth changed because the stars changed, right? So just taking that seriously, like if they say it in Japan and in Norway and in South Africa and in Central America and in Greece, you know, if they have the same story all over the world, why not take it as, you know? So that started Wal Thornhill's journey, and Wal Thornhill and Don Scott are and Eduardo Cardona are like three people who really launched into this study and created a movement that became the electric universe. Yeah. And I think one of like, for me, so the question might be, you know, when did you really get on board, you know? And petroglyphs, those carvings in the stones, the electric universe people, I forget which ones were focused on it. This was back before I joined. And you would see the same images all over the world carved into stones, strange images. Sometimes there was one of them is called Squatting Man, which has...
Yeah, that's all over the world.
All over the world.
Yeah.
And Squatting Man always has these circles between the whatever that is and whatever that is. But then there's like 12 other geometrical shapes that there's squatting man there. There's like 12 other geometrical shapes that also show up all over the world. And some of the people in the electric universe had the theory that this could have something to do with electricity. We don't know yet, because that was part of how they were thinking. A really famous Los Alamos plasma physicist, Peratt, this is his last name, spacing on his first name, Anthony Peratt. He shows up at one of the conferences where they're talking about the petroglyphs. And halfway through, he like just stops everything and says, where did you get these images? And they're like, well, they said it again. These are petroglyphs. And he said, those are classified images. That's what happens when we have our most powerful plasma discharges in our reactors. The most powerful plasma discharges that we can create make all of those patterns.
Interesting. Okay.
And then Peratt went one step further, and he said, well, what if those discharges were happening above the North Pole and the South Pole, because that's the primary place where the electricity comes into and out of the Earth. And then let's take the latitude of the image around the Earth and see if the geometry of how they drew it changes with latitude. Like if it looks, do you know what I'm saying? If you were to kind of go, if there's a discharge happening here and you're standing here, it looks different than if you're standing here on the Earth, right? Yeah. And sure enough, the geometry of the images
lines up with the petroglyphs.
Yeah. So for me, that was like, okay, I am done. Like, is this a possibility? Yes. I'm getting very convinced, and that kind of and it's been all out for me.
Okay.
Yeah. Since then.
Love it.
Yeah.
So tell people what it is. Tell people just in general terms. Maybe take a few minutes and just explain what is the electric universe theory.
Yeah. So if we could put up a couple images, it'll help talk. And again, this is Michael Clarage talking. There's no textbook yet.
Right.
It's not like, and I've gotten my ideas from a lot of other sources, some great teachers that I've had. So I didn't make up a lot of what I'm going to show, but it's very much.
Yep.
Okay. So what we're looking at here is a hierarchical cosmology, and you can see these are modern terms that we have. A galaxy is a gigantic organism. Inside of that, there's hundreds of billions of smaller organisms called solar systems. Inside of every solar system, there's smaller organisms called planets. I think on most planets, not every planet, there are smaller organisms like us, trees, birds, squirrels. Inside of us, there are hundreds of billions or trillions of smaller organisms again. This to me is like, you have to start here, and that we live in a world that is constructed of worlds within worlds within worlds, and every creature has its home in some other creature, and is made up of other creatures. And I'm sure there's a stopping point. I think there is a place where it all comes from, so it's not like it just keeps going forever. But that's just
the organism, the ultimate,
exactly.
The organism that contains all organisms.
Yes, exactly.
So when you say organism, is it living?
Yeah, living.
Yeah.
So and again, not everyone believes this in the electric universe community, but to me, it is absolutely essential. We live in a living universe. We will not understand anything. We won't even know what we're looking at if we think we're looking at a dead thing. We can't even fathom. We think we know what the sun is, but if we don't incorporate that it is a living being of, to us, probably divine intelligence relative to us, right? Then we won't understand what we're looking at. Yeah, we'll ask the wrong questions. We'll make the wrong measurements.
And why? What is it about? What is it about life, or what creates that? Is it the fact that it's, or the concept or possibility that it's a conscious being, that the sun and that the galaxies are all conscious and interconnected through their electricity and that kind of is it the electricity itself that has consciousness within it, or what? How does that work?
It's a great question. And I'm trying to tease that out myself. I don't know why it is that the electric universe cosmology fits so well into this. So I don't have an easy answer for it. But there is something about, yes, what you mentioned, that electricity is like it's the vehicle for consciousness. Something like that.
The idea of a dead universe just kind of sucks.
Yeah.
I mean, it's just kind of depressing.
It is so depressing.
It's very scientific and boring and depressing. The idea of a living universe where there's consciousness within all things or most things is far more interesting, and it makes you feel more connected and more a part of something,
Totally
and less separate and separated from the universe. It makes you feel like you're a part of the universe itself. So it's fascinating. I think it's definitely worth considering as a possibility, and it feels like maybe they've kind of written themselves into a bit of a hole, and they seem stuck in a number of cases, and feels like maybe just life itself and a lack of an understanding of what life is and what it means to be conscious or aware, because for them the entire consciousness of everything is just within the human brain, and there's no other life anywhere. It's just a very dead, dull, boring, just kind of depressing way of looking at things.
And I think it's worth asking, since modern scientists are so stuck on well, prove it to me. What evidence do you have? I would ask, what evidence do you have that the sun is not alive? I don't feel I should need to prove to you, if you're so blind that you can't feel that. But what evidence do you have that the Earth is not alive? Really? I mean,
Yeah.
because we could have there could be that would be a great little topic. I don't want to do it today, but what is life, and how does it manifest? And if you could make a list of 40 things and then see that, all 40 of those apply to the galaxy.
Yep. Love it.
But more of it is, okay, here's a cool thing. Instruments can only measure what they can measure. What am I trying to say? Oh, so like if I had a magnet and then a piece of wood, the magnet, when you have a magnet and you put them next to each other, you can tell that there's a magnet there because they see each other, they sense each other, they affect each other, right? So you need a magnet to know if there's another magnet around. A piece of wood won't tell you if there's a magnet around, because a piece of wood doesn't have magnetism, right?
Right.
So how are you going to perceive whether or not something is alive? You need another living thing to perceive if something else is alive.
Right.
So no instrument you make out of metal.
You're saying that scientists aren't alive? No, sorry, that's not where you were going. Sorry, go ahead.
No instrument you can make out of glass and metal and silicon will ever tell you if something is alive. But you can be sitting, you can pass a dead squirrel on the street and you're like, that is a dead squirrel. How do you know? Because I'm alive and that's not, right? It's
Yeah. All right, so fascinating. So you've got all these different levels of life that exist within the universe, from small to very large, and we can only see down to the cellular level and up to the galactic level, but there's almost certainly something beyond both the galactic level and the cellular level, and we just can't we can't see it because we're in the middle of them. So
something like that.
Yeah.
So let's go to the next image. So electric universe. So zoom just to that top one there. There is a 100 volt per meter electrical field on the surface of the Earth. Your head is 200 volt difference than your feet. 200 volts is the amount of voltage in the wall socket. If you've ever gotten hit by a wall socket, you know.
I've been electrocuted.
Yeah, I think all of us ordinary guys have been electrocuted at some point in our lives. So that gives you a kind of a flavor for what 100 volts is, or 200 volts. And some of us also know what a 9-volt battery on the tongue, that kind of gives you a feeling. Voltage is a mysterious thing. It just is. Maybe later we can talk about what voltage is. But to think about that, between your head and your feet, 100, 200 volts of difference, that's a lot. Like, you could do a lot with that. What is that doing there? How come no one talks about it? Is it important? Standard Earth science says that it's irrelevant, that it's doing nothing. And this is another theme in all of everything I'm going to talk about, is nature usually doesn't work that way. Nature usually doesn't do elaborate things that serve no purpose. That's not, in fact, nature seems to be like incredibly brilliant to design structures that perform multiple functions at the same time. 2 functions, 40 functions. So if there is a 100, 200 volt difference every meter that you go up into the atmosphere, that is there for a reason. And we should figure out what that is there for, right? That keeps going up. And although it's very complicated, this is just gives you a feeling for it. By the time you get to those clouds, hundreds of thousands of volts difference. That is enormous. Like, again, what is it doing there? What's its function? Why is it there? We see it manifest most obviously in terms of lightning. Like, that's like our experience of that enormous voltage difference is that bolt of lightning.
Okay.
So that gives you a feeling of how much tension is between the clouds and the ground.
Right.
If that tension gets released in a lightning bolt, that's a lot of tension. What is that tension doing? Why is it there? Okay, next slide. And then that continues up into the atmosphere, and maybe we'll look at some of this later. The above the clouds that we see with lightning, above them, there's other forms of lightning, which are kind of mysterious in the sense they haven't been studied much. It's a classic story. When airplanes started flying, so in the 50s and the 60s, pilots would see above storm clouds, they would see these blue flashes go up into space, and then they would see these red flashes go up into space, and then they would go to the local university geophysical department and say, "Hey, I saw this thing. What is that?" And they were told for about 10 years, "You're hallucinating. That's not possible. There can't be lightning going into space."
Okay. They were wrong.
It's just classic. It's like somebody sitting at a desk who has books tells you, who just flew up there,
Right.
that you can't be seeing what you're seeing.
Right.
You would think that someone would be like, "Tell me more. Where did you see it? Take a picture next time. Just give me information," right? And eventually the number of photographs overwhelmed the geophysical community, and now it's part of the story. Oh, yes, now we know that there are these things that go up, right?
Okay.
We know about them now. And then you continue out even further, and the Earth looks, you remember the pictures of the atoms in school where there's a positive center and then the negative electrons that go around?
Sure.
So that is as much of a cartoon as that is, it also conveys a lot of truth, that is a cosmic pattern. And our planet, other planets, that they have around them a ring of positive charge and then rings of negative charge. And depending upon how much energy the magnetic body of the Earth has, you will have maybe one shell of those negative charges, or maybe 2 shells. And if it's really charged up, maybe 3 shells. And that's exactly what our picture of atoms is too. If you talk to people who study atoms, they tell you, well, a quiet atom just has 1 shell, but if you zap that atom, all of a sudden you'll have 2 shells.
And by shell, what do you mean?
Yeah, it's
Is it just the distance from the nucleus that it's orbiting?
Yeah, like that.
Okay.
Definitely. That's a good way to put it.
Yeah.
Very good way to put it.
But it's not really orbiting, right? That was the thing forever, that it was orbiting, but now it's like it has a probability of being in a specific place on the shell.
So when I get to the discussion of time, we can come right back to that.
Okay. Got it.
You need other dimensions of time to resolve that conundrum.
Okay.
Yeah.
Gotcha.
Okay.
All right. We'll come back.
So next slide. Yeah, so we have to envision planets more as these kind of, the rocky body of a planet is real, just like my bones are real, but our bones are more kind of like a center structure, and then around our bones, just speaking roughly, we have all this other stuff, right? But then around all this other stuff, all of us have magnetic bodies. I don't know if you've ever seen any of the research into that. There's plenty of people who can see that. They see auras and stuff. That's an actual function that our eyes actually have. It is not some woo-woo thing, right? We have, so it was pigeons. We finally put the picture together that pigeons in their eyes have a molecule that can see magnetism.
Wow.
Yeah,
That's cool.
it's very cool. So they have the molecules that see light, but they also have other ones that see magnetism. And so the pigeons are flying along these highways, right? Humans have the same gene.
So if pigeons do, then is this what birds are using to migrate in general?
Yeah.
Yeah. Okay.
And humans have the same gene in our DNA, but it's usually not expressed.
Okay.
But
Gotcha.
in some people it is.
Okay. Okay.
Yeah. So this is a very real thing. So we have to picture planets not as rocky things, but as, I think it's good to think of it as they have a magnetic body, an electromagnetic body that is just as much a part of their body as the center rocky area is. So we are not living on the Earth. We are living in the Earth.
Right. That's for sure. Yeah.
It's a huge difference.
Yeah. I mean, just with the atmosphere, we're living in the Earth.
Right.
But you're saying that there's this whole other level of
Yeah.
electricity that just kind of encapsulates the entire experience.
Yes.
And so the Earth is then kind of the atom, I guess, is a microcosm of the Earth in some ways.
In some ways, yeah, there's patterns. There are definitely geometric patterns that repeat and repeat and repeat.
Yeah.
And scroll up a little bit, Ryan. That one right there, this is sometimes called a torus or a toroid. It's like a donut shape.
Yep.
Okay.
Yep.
That donut shape is everywhere. You have a donut shape. If I could activate my magnetic sensors in my eyes.
My wife does not think I have a donut shape. She's very impressed with my shape. I got to tell you, I got to be honest. Been lifting, man.
I was impressed when you
working out
walked in
hard.
with the rocking the biceps.
Oh,
I was
thank you,
like,
yeah.
this guy does everything, doesn't he?
I had to put the hoodie on. Otherwise, it
So
just...
we literally have it comes out of us and it goes around
All right.
into a donut. That's our and its center is right here.
Yep. Yep.
So that's our magnetic body shape.
Okay.
And it's and the complexity, there's no end to it.
You're speaking Bob Greenier's language now.
Oh,
with
yeah.
with the toroids and the circle within a circle within a
Exactly.
circle.
Exactly.
Yeah.
Yes.
Or, yeah.
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 A
Basically.
torus within a torus
There you
within a
go.
torus.
Thank
Right.
you.
Exactly.
Yeah,
Right.
yeah.
Yeah. And so we'll see this in other places today as we talk. So we have to picture the magnetic body. So the electric universe. So coming back to this, here is a schematic. This is not an artistic drawing. It's an engineering drawing that all planets are electrical transformers of solar electricity and magnetism. Do you remember ever learning how AC transformers work? So you have a coil on one side, coil of wire, and you're driving that with an AC, an alternating current. This way, that way, this way, that way, this way. And then next to it, if you put another coil that has a different number of windings, how many times it winds around, you can change, it's called step up or step down. You can step up the voltage or step down the voltage. So that's one way you create. This is Tesla. This is all Tesla stuff. How you create, if you just have 20 volts over here, how can you create 10,000 volts? Well, 20 to 10,000 is what, 500? If you have 500 times more windings on what's called the secondary coil than you have on the primary, that will step up the voltage to 10,000 volts. So that idea of you can transform energy, electricity and magnetism, with coils and circles and coils, that is what's playing out in every single solar system, on every single planet, and on every single moon. Is this, there's the energy that comes from the sun. If we had no atmosphere, if we had no magnetic body of the earth, it would just fry the earth. We would just be barren rock that would be 500 degrees during the day and, negative 200 at night.
Like Mercury.
Right? Exactly. Right. So these layers that planets have on them, the watery layer, the gaseous layer, and then these 7 different magnetic layers, that you can, it's quite literal. It is stepping down the solar energy. It's making it digestible.
Interesting.
Yeah.
Interesting. So, and why can't we see it?
That's a great question. Partly it's because, like I said, our eyes don't see it. But when we put up,
It's just outside of the visible spectrum,
Yeah.
outside of like light. We can see what, 5% of the visible spectrum of light or something like that.
I think it's good to talk about it in terms of octaves.
Okay.
So our usual color palette is 1 octave of vibration. So it's literally like going from C, D, E, F, G, up to C again on a piano. If you, that's a doubling of sound vibration, is 1 octave. That's what our eyes see. They see 1 doubling of frequencies of light. Okay. So we see 1 octave. Okay. How many octaves are there in that first picture that I showed, stretching all the way from, atoms up to the creation of everything? I don't know. Lots of octaves of radiation. Maybe I don't know. So yeah, why can't I look up at the sky and see the magnetic body of the Earth? Partly because these things see 1 octave, and what's going on out there is not necessarily that octave. However, we have the northern lights. That is a direct way to see. That's a case where the electricity coming into and out of the Earth excites the atoms and molecules into a frequency that we can see. So if you look at, and next time you look at the northern lights, a video of the northern lights, try to take in that you're looking at the sun literally feeding the Earth. It goes both ways. It goes in and out and in and out. Yeah, you're looking at.
So they're connected in a sense.
They are directly connected.
And what would you call the connection point? What is the string?
Yeah,
Or is that farther ahead?
no, it's fine. It's good. The in the 60s, the view. Well, I should back up. In the early 1900s, the view was there can't be anything out there because space is empty. And a scientist named Christian Birkeland was trying to explain the northern lights, and he packed his magnetometers into his case and traveled north, to the ice and set up measurements and stuff. And he came back with, he said, no, I think there's electricity flowing. And he was told, no, that's not possible because space is empty, right? Fast forward, eventually we throw up a satellite. Boom! And luckily we put magnetic and electric sensors on that satellite. And it was just like, as they say, scientists were surprised.
Okay.
Because there was so much electricity and magnetism up there that it was just like, oh my God, like, how come we didn't know that, right? So it's a strange story. It's almost as if we've been, I don't want to say excluded or hidden. It's strange. It's like we've been excluded from knowing all these things. I don't know.
Yeah, I mean, it happens anywhere. Once you kind of define what you think reality looks like, then you're limited to that view, and anything else that contradicts that, you just
amazing.
write it off.
It's
And
amazing.
yeah, it just turns into the way that things are. So that thing that happens right there is what kind of limits in different creative thinking and different ways of looking at
Yeah.
things. So that's what this podcast is about, to try to look
Yeah.
at some of those other possibilities. So.
I want to finish the connection
Yeah.
story. So in the body, human body, the connections to us seem permanent. Like there's a big tube coming out of my heart, and it goes to other tubes, right? What we know from data so far is that from the sun, there are millions and millions of little tubes. So if we could see it, it would be like, you can just imagine gazillions of threads coming out of the sun. And then a planet in its orbit is connecting with various of those threads as it goes around. So we don't know yet whether or not there's a permanent connection, like an artery between the sun and each planet. We just don't have the data yet. But we do have data for what I just said, that it's like there's arteries going everywhere, and then the planets pass through them and then connect as they go through.
How could we begin to see this? Like, what would we need to send a certain satellite up into space that has the ability to look on a certain frequency or whatever? Like, how can this be proven?
Yeah. In one sense, I think we're doing the best we can. We're shooting up our little satellites. And a satellite is really just a point, So you're flying this little point through this gigantic three-dimensional organism, How do you collect the data you need if that's what you're limited to? So then we try to put that together.
But there's no camera that can see it. There's no way to
Not yet.
to view it.
Not yet.
Okay. We can see lightning, we can see, which is plasma, right? Which is going to be different than the filament or whatever that connects a sun to a planet.
It's probably, it probably shares a lot of the same properties.
Okay.
But again, it's from another world. We don't have the things to see it. At least not in our usual state of awareness.
Okay.
So there are.
Is it almost a different dimension then?
Yeah, I think that's a good way to put it. Too.
Okay.
Yeah.
Interesting.
Yeah.
All right.
Let's see. Now, just one step further with this model here. So remember how I said that planets are digesting or transforming down energy from their sun. The same is true of suns relative to the body they live in. So suns also are transforming, but this time galactic energy. So the galaxy is a creature of really unimaginable size, extent, and its energies are just... A star also just couldn't live in that environment if it didn't have some way of digesting that incredibly fine energies. And so that's part of the electric universe paradigm, is that stars are shining because they are digesting galactic energy.
Okay, so no fusion.
I don't have a horse in the fusion race, but I think I would say no. I'd say no fusion.
Okay. But within the electric universe community, does fusion exist in combination? Does fusion exist for anybody?
I'm sure for some people are way on the, hey, we've disproven the fusion model, and I'm like, I don't know if we've disproved anything.
No, I don't think so.
Yeah, there's some really strong evidence that, so the The galactic energies are coming in. The star is transforming them for just to live. It's just living. It's just doing its thing. It's like eating broccoli, right? I'm just eating broccoli to live, and then I digest the broccoli, right? So the star is just living and eating and all that stuff. And then that photosphere, that's what we see. And the photosphere is where a lot of elemental transmutations are taking place.
What, the photosphere? What
So
is
the
that?
photosphere is what we see as the sun. That's that bright ball in the sky. That bright ball in the sky, the edge of it, the surface of it is where the light comes from. And the fusion model, the previous model of the sun, says that there's a thermonuclear bomb going off in the middle of the star. That energy makes its way out and then finally bursts forth from the surface. The electric universe paradigm is very different. It says there is, just what I was saying, transformations going on of incoming electromagnetic energies and other energies, I'm sure. And the surface of the sun is where we see that, that's where we can see where the transformations are taking place. And part of what you do is you can change carbon into nitrogen, and you can change hydrogen. And because at the solar level, at the solar world, it can do whatever it wants with elements. Just like our body can do whatever it wants with molecules. You want to make some glucose? Fine. Give me a potato. I'll just and I'll make you glucose. That's just what we can do. Anything. Our bodies can do anything with molecules, right? At the solar world, it can do anything it wants to with elements. It can make carbon, nitrogen, oxygen.
Okay.
And I say that's taking place primarily on the surface of the sun. And there is evidence for that. It's not just a thought. Yeah.
Okay, so it's taking stuff from around it and transmuting it into, so it's like a living organism that's eating and excreting energy, essentially.
Yeah. Yeah, and sending off whatever's needed at Jupiter and whatever's needed, elsewhere.
Through through solar radiation, but through the filaments that
Yes.
exist and that connect the planets.
Yeah. Yeah. Now, just as we said a second ago that we don't live on the Earth, we live in the Earth, right? The same is true with the body of the sun. We live in the body of the sun. The body of the sun is not that ball in the sky. The body of the sun, have you heard of like the heliopause or the helio boundaries? That's where the satellites recently went through. I forget if it's the Pioneer or the Viking ones, but right? Okay. That is probably the extent of the body of the sun. So whatever that ball in the sky is, I don't know, maybe the sun's heart or maybe its brain, I don't know. But the sun, the body of the sun is this enormous thing. So all the planets are living inside the body of the sun. You and me are living inside the body of the sun.
Yeah, fascinating. And then the sun is living within the body of the galaxy.
Exactly.
Yeah. And the galaxy is living within the body of what?
Yeah, so you've probably seen them without. There's enough telescope data that we can map out what the structure of the world that the galaxies live in is. It's pretty amazing. It's pretty amazing to have telescopes that can tell you that, right?
Yeah.
And it's this filamentary world. Thousands, millions of galaxies are strung out on filaments that are all connected, and there's giant nexuses of millions and millions of galaxies, and then from that come these filaments, and those filaments are made of galaxies, hundreds, thousands of galaxies.
Okay, all right, fascinating. So that's kind of the story. That's kind of the overview
Yes.
of the electric universe in general.
I would say so.
Yeah.
It's
Okay.
a good
Excellent.
overview.
Yeah, fascinating. Good stuff. Okay, so then where do we go from here?
I was just going to ask you that. We could talk about a few examples,
Okay.
or if anything else occurs to you, we could.
Yeah, I'm sure I'll have a lot of questions, but yeah, let's go through some examples.
Yeah. So let's look at filaments in the interstellar medium. Why you need an electric cosmology to explain what's going on there. What we're looking at here is an image from the Herschel telescope. The Herschel telescope, went up into space. I forget the year, 2013 maybe. And what came back? This is an example of what came back. This was one of the headlines were all over the place. Scientists are shocked because no mainstream astrophysicist predicted anything like this, right? However, electric universe theorists were like, oh, you're going to see filaments because that's how plasma discharges work. So plasma takes a little bit of explaining. We're very familiar with solid, liquid, gas. That's most of our world, okay?
Well,
And
most of the world's plasma. I mean, most of the
universe is plasma.
Yeah,
right? So
yeah.
plasma is this other state of matter
Yeah.
that really has other properties, just like gas has properties that solids don't have, and vice versa. Plasma has properties that there's actually it would be better to have a solid, liquid, gas. There's not just one thing that's plasma. I would break it up maybe into 4 different kinds or something. So the ladder goes up through several different types of plasma, I would say.
Yeah, plasma is like 99.99% of the observable universe, basically. I mean, it's almost everything.
And plasma is very high energy. So you know how you have your ice cube, you add energy and you get liquid.
Yeah.
And you add a lot of energy and you get gas. You add even more energy and you get plasma. So plasma is very energetic. And so what you just said, 99% of the universe is plasma. Just sit for a moment with that and ask yourself, where does all that energy come from? If the most energetic thing I can imagine is 99% of the universe, that's a lot of energy.
And your thought is that it's just there in balance and feeding off of the universe itself, off of the ether. It's eating. I mean, all the stars, all the galaxies, all the plasma that exists within the universe is just like the sun. It's just sitting there in balance, and it's just living.
I know it's living, but I'm a little bit stumped on. I can't even fathom how much energy is in the universe.
Yeah.
If 99% of it is this hyper, energized state, what does that even mean? I don't know.
Okay.
It could be. I mean, how I actually in my own mind see it is often when we talk about things as scientists, physicists, we are using models and shadows of models. And we often believe our models and think that the model is really what I'm looking at. But it's not. It's just a model. And often it's the shadow of something. It's not even the real thing. So we were talking earlier about the little cartoon of the nucleus of the atom and then the circles of the electrons. It's a cartoon, it's a shadow, it's a slice, it's just so when we look out with our instruments and we find that 99% of the matter out there is in this highly ionized state, that's just one way to say it. You're just talking about one attribute. And what are the other attributes that are go along with that? And this is where you get into older ways of thinking and talking, like what is the glory of God? What is the mind of God? What is the love of God? These are things that we're always historically talking about as so overwhelmingly powerful that we can't even conceive of them in our human form. And maybe one of the attributes of that is that you need to have 99% of the universe in this highly ionized state. That's how it has to be in order to even, have a material container. To have a material container for something that grand, it has to be a universe filled with highly ionized plasma. Yeah. Okay. So the telescopes go up, we see filaments. Filaments is if you had a bunch of dust and gas and molecules sitting out in space, and if you shot a lightning bolt through them, it would make filaments. So one way to say it is you're looking at a lightning bolt in space here.
Okay. So this exists between the sun and the earth, for example, but
well, what we're looking at here,
But we can't see it, but we
Right.
can see this one because it's
we can't see it with our eyes. This was a telescope that was sent up outside the atmosphere of the Earth that had cameras that could see much slower octaves of light frequencies.
okay. So would those cameras be able to see the connection between the sun and the earth?
I don't know. It's a great question.
Okay. Okay.
Yeah.
So what makes this different than that, I guess, is the question.
Yeah. Okay. So one of the things that's different about this is that first off, it's the size. So the bright dots you see there are stars that are coming into being. So the distance scale here is so much larger than we can actually imagine, frankly. The distances that we're looking at is one big difference. Everything
Okay.
I was talking about how huge the sun is and how big the body of the sun is,
Yep.
that's just a point. That's just a dot on this picture.
So is this what we're looking at here is the formation of an early galaxy, I guess?
Stars within our galaxy.
Within our galaxy.
Yeah, so this is close to us, within our galaxy and close to us.
Okay.
But again, the distance scales are so big, it's hard to really fathom. But it would be comparable to say to a scientist at the tip of your finger, pointing their telescope towards, say, the second joint of your finger. That's roughly what the analogy is.
Okay.
We're not looking across all the way to the feet, right? We're just turning our telescope, looking at something kind of in our neighborhood.
Okay.
Okay. So as an astrophysicist, part of what the community has done over the decades is apply math to what's going on in astronomy around us. And this is a equation that I used to analyze some of these filaments. The first term is gravity. It says gravity wants to bring things in. It wants to collect things together. The second term with that I squared is electric current. That also wants to bring things in. We can talk about it later. If you shoot electricity through something, it will bring it together into filaments. That is what it does. It brings things together. And then on the right-hand side, we call those expansive terms. That's things like temperature. So if the filament gets hot, it's going to want to blow apart. It's going to want to expand and blow apart.
Okay.
Okay, so lose the equation. And let's just look, scroll. So we'll just go through some of these pictures. These are a variety of filaments. What I did here is I chose good data. I wanted to work on data. We're looking at filaments in different astrophysical settings. And the question is, how much electric current do you need in order to make that filament? What?
A lot.
A lot, right? Exactly, a lot.
Yeah.
Yeah. And so we'll look at some of the pictures just on each one. These are you can kind of see each one of these has a filamentary nature, and that what we're looking at there is dust and gas and organic molecules that are out around us in our local neighborhood. They fill the galaxy, and they are being brought together into filaments. And the electric universe model is there's electric current flowing through there. And that's the physics of why that dust and gas and molecules are coming together and making filaments, like branches. So we're just looking at various branches, filaments right now. This is my favorite in the world. What I was saying about plasma has different natures to it. Okay. What is that green and blue thing off at the end there?
Yeah.
Because
I was going to ask.
Because it's clearly the end of something, right? You can see the off to the right, there's those bright orange filaments that are feeding over to that blue and green thing. And on those filaments, there are stars forming. In those filaments, there's all kinds of things. There's organic molecules in those filaments. What? I thought organic molecules were just here, right? No, dozens and dozens and dozens. A Japanese group even found amino acids in these filaments. Like what? I thought amino acids were just things that we made here on Earth,
How did they find that?
because every molecule and atom gives off a very particular signature of light. This is really cool. It's called spectroscopy. We've all seen if you put light through a prism that it breaks it up into the colors. That's spectroscopy. You're taking your light and you're breaking it up and you look at the colors. If you next time you're at a fire, a wood fire by your fire pit, and you have your prism with you, you can break up the light from the fire, and most of it, there's like kind of this wash of different colors, very dim, but most of what you're seeing with the fire is just this one particular two wavelengths that are very close to each other in the orange. It's called the potassium line. So most of what we see in a fire pit is just the potassium atom that's giving off its signature light. So you can look at you turn your spectrometer towards these filaments, you see a very complicated spectrum. You can figure out what molecules are in there.
Okay.
Yeah.
That's cool.
It is cool. And then
So if I just go out to my fire pit and bring a prism at night and just sit it next to the fire pit, it's going to break up the colors for me?
Yeah, I mean, you might have to play with it quite a bit. And
Okay.
yeah.
Okay. That's cool. All I need is the prism. I don't
Well,
need...
what you really should do is get the light, have the fire light go through a little hole.
Okay.
And then send that little hole of light through the prism, because you want to have just one little beam.
Okay.
Ideally.
Got it. Okay.
Yeah.
I'll try it.
Okay, so let's just scroll through. Oh, these are these are wild. These two right here. What we're looking at here is the center of our galaxy. So there is this line of sight that we can point some of our telescopes. This is not visible light. This is radio signals. And we can see the center of our galaxy. And this was, again, the headline. Scientists were surprised to find at the center of our galaxy are these filaments. The center of the galaxy is so energetic. It is so hot there that none of that should exist. It should just be this wash of just overwhelming, I don't know, sea of plasma. What do we find? We find structure. We always find structure. Nature makes structure to perform functions. We are looking at the center of our galaxy at these plasma filaments, and they are doing something at the center of the galaxy. What they're doing, I don't know. We could probably make some reasonable guesses.
So where is so the supermassive black hole? Are you?
There is something there. The whole concept of what a black hole is so almost useless. Everything we've heard about what they are, how they formed, it's almost like just try to rid your mind of that whole story. Do I think there is something there? Yes, of course there's something there. But our cartoon picture of black hole just do away with that.
The gravity thing, I want to get into the gravity thing and your thoughts on that too. But my question was, in this image, where is the exact center where the supermassive black hole would be? Okay,
Yeah.
So it's
Good
not
question.
that big, bright yellow thing?
I don't think so.
Okay.
Good question.
All right.
Yeah. Okay. So now if you there, look at that thing. Isn't that gorgeous? I mean, what the heck is that's in the center of our galaxy? If I told you that was eggs in a fallopian tube, you would probably believe me.
Looks like a virus or a bacteria.
Or if I told you it was a bacteria and that filament is a little tube that it sends out to feed, you'd be like, oh, that's really cool.
Yeah.
Right?
Or a sperm fertilizing.
Exactly. Oh, that's right. I
something.
could tell you that's a sperm fertilizer. You'd be like, oh, that's so cool. Yeah, look at that, right?
Yeah.
So to me, when I look at these images, I am looking at some activity of some living creature. That's just how I see it,
But this is also the center of the galaxy?
Yeah, it's in the center of our galaxy.
So taken from what, different angles or different times or what?
Well, if you scroll to the very top of the post here, Ryan, that is where all this comes from. So that, again, your question is great. Like, well, where's the very center?
Yeah.
So I don't know. It's a great question. But
It's
this
got
is
to
the
be that
larger.
orange thing. It's got to be the orange area in the
I don't
middle.
know. I don't know.
Yeah.
But this is the larger picture of the center of our galaxy.
Okay.
Again, scientists were surprised to see all that. Okay, so let's look at some numbers just for the sake of numbers. We can blow right. Yeah, so stop there. On the right-hand side is the calculated current it would take to form the filaments that we were looking at. So the list here is the different filaments that I looked at. So you're looking at 10 to the 13th, 10 to the 16th, 10 to the 20th amps. What does that mean? That means a 1 with 13 zeros, or a 1 with 16 zeros, or a 1 with 20 zeros. These are currents that are electric currents that are really unimaginable. I can't imagine what 1 with 20 zeros means for a current, right? But it kind of sets you back, like, wow, that's a lot of electric current.
Yeah. It's galactic level.
Galactic level electric current. Yeah. And what I found from this analysis is that the gravity term, remember how I said gravity is there kind of contracting things, bringing things in? The gravity term is minuscule relative to the electric term. Yeah.
So the gravity explanation for the universe and for the formation of stars and solar systems and whatnot is directly contradictory to electrical universe.
I think so.
Yeah. So what are your thoughts on that, and why doesn't that make sense to you?
Yeah, that's I guess one way to say it is from the physics, if you go hardcore and you're like, no, let's sit down and I want to see equations, you know. I'm not going to let you wave your hands. We're going to sit down, we're going to do equations. Gravity can't collapse anything because then it would be doing work on itself. I know these are just physics terms I'm throwing out. And a system can't do work on itself. That's not physically possible. You can do work on something else. Like I could lift that interesting, what do we call these things? There's a name for these.
Ottoman, maybe?
Ottoman, right.
I think, maybe.
I could do work on the ottoman and lift it up. But the ottoman can't lift itself up.
Might just be a footstool. I don't know.
I think it's a footstool.
Yeah,
I think
but
you're right.
go ahead. Sorry.
Yeah. It can't lift itself up, right? That's kind of like, okay. So you run into the same physics problem when you want to have a bunch of gas and dust that collapses. It's doing work. It can't do work on itself. So that's one explanation. That's one way to answer your question. Another way to answer your question is that it's never actually been proven anywhere. Like we don't have any actual like experimental observational cases where gravity formed anything. And if you just run the picture in your head, okay, let's imagine we start the movie at some point in our solar system's gestation. Somebody opens a textbook, okay, when the solar system was 1 billion years old, there was a bunch of rocks flying around randomly, all gravitating and flying around. And then they stuck together. And you're like, well, wait a minute. These things are traveling, I don't know, thousands of miles an hour, 60,000 miles an hour. They hit each other, and you tell me they're going to stick together? No, I think if they hit each other, they're just going to create mayhem, right? So the whole picture of how does this work gravitationally has some serious gaps. And then you got to bring in all kinds of adjustable parameters.
I for sure agree with that. Yeah.
What's that?
I for sure agree with that.
Okay.
That there's some significant holes in the gravitational model,
Right.
and that it doesn't explain everything.
And people have been running the computer simulations for decades now. And there's all kinds of these, what they're called adjustable parameters. Well, what's the ambient magnetic field? What's the radiative coupling between certain bits of silicon that are asymmetric? And how much heat can I radiate off? Because that heat will radiate off, and that'll help the system cool down and collapse. And there's like 40 of these parameters you need in a gravitational simulation. And you are frankly free to set those parameters however you want. And so if your job as a graduate student is to write code that will show gravitational collapse, you can adjust those parameters and show gravitational collapse and get your PhD, and, you can do that. Whereas what's different about the electric case is that's what electricity does. Like I was saying, we have plenty of laboratory examples. We have the example of lightning. When you send an electric discharge through something, it will it will organize. It will organize into filaments. And then if you look at and with high-speed cameras, you can look sometimes with lightning bolts. You'll see the same picture we saw on there. On the main bolt, there's these dots, which are like further compressions. So this just happens. This is just what electricity does. I don't need to invent a whole set of 42 adjustable parameters. I can look out in space and go, oh, that's electricity forming something, because I've seen it here on Earth.
And so where does the electricity come from?
Woo! Yeah.
Yeah.
That's a great question. Yeah.
You're just out there in space.
Yeah. Well, if you scale up, that's why I started with that cosmological, hierarchical worlds within worlds. So our cells are electrical. So this is now this is the new direction of medicine. For the last 60 years, we've had biochemistry. And we've all grown up in that, and we believe, most of us who are associated with medicine believe that that's what life is chemistry. Life is chemistry, right? Biochemistry. Okay. No, it's not. Chemistry is an aspect of life. Life is just as much electrical as it is chemical, but we haven't really studied it that much. Okay, so every single cell in your body has like a 70 millivolt potential from the inside to the outside. That's part of what keeps the cell alive. And then if you take that and multiply it by the trillion cells that are in your body, that's a lot of electricity. Actually, I haven't done the calculation, but it's a lot. Where's that come from?
Yeah.
Yeah. So but it kind of sets the picture of, oh, yeah, it's not like there's not some battery over there. This is really complicated. I'm eating things. I have structures and systems in me that take that.
But the moment you die, the electricity's gone.
Gone.
So is the electricity life itself?
Yeah, I would say no. I know you and I talked a little bit about this before. How I see it is life is its own something. It's not electrical, it's not chemical. It's a separate something. And that something, that life, can inhabit a electro-biochemical system like you, or not. It can leave you, whatever that is. And this whole obsession with trying to explain life in terms of chemistry or electricity, I think is just missing how things are set up, I think.
Okay.
And then if you ask me, well, then what is life?
Don't know.
I don't know.
Yeah.
But you could ask the same question about what is electric charge. I don't know. No one knows what electric charge is, right? So these are mysterious things.
Okay.
But the electricity somehow seems, in order for life to manifest, certainly on Earth, you have to have electrical systems. That I'm pretty clear on.
But why do you think they're two different things?
I think because it can be, I think because my experience of being with someone when they died had a big effect on that. Like something was there, and then that something was not there, and it happened fast. The matter was the same, so to speak. I'm quite sure the chemical reactions were still going on in the body.
Why?
Well, just because of that's a good question. Why? I don't know. Maybe not. I don't know. I guess based upon my previous education on how chemical reactions happen in the body, but not because of experience. But something leaves.
I mean, the decomposition process begins immediately.
Yeah.
And once the chemical once the body's dead and the chemical reactions stop.
Yeah. Yeah.
Who knows, I guess.
Who knows?
So could be, could not be. We don't know, but it's speculation, I guess, at the end of the day, either way. Yeah.
But I think it does come back to what I was saying before, that in order to perceive life, you need a living instrument to perceive whether life is present or not. It's related somehow to all this.
Unless the living organism the living organism can perceive itself, I guess, right?
That's a great question. Can you perceive your living?
If you're the only living thing on Earth, would you know that you're alive?
Yeah.
I think your consciousness would be there. I mean, yeah.
Wow. Don't know.
Rabbit hole.
Rabbit hole.
I think your consciousness is there. If you're alive, your consciousness is there. So you wouldn't need a second party to confirm it necessarily. But
let's see that picture. So this is from a great website called The Sky Live. It's wonderful. I'm on there a lot. It shows you where the planets are. You can run it. You can speed it up and watch the planets circle around. But I just want to start with this is, if you're in school, you're taught that this is what the solar system looks like. Mm-hmm. There's that bright thing in the middle, and then there's the planets that orbit around, and there's emptiness in between. Right. Okay.
Space is empty, yeah.
Right. So that is the picture. And all of us have, whether or not you are an astrophysicist, you have that picture somewhere in you. At some point in your education, someone showed that picture to you.
Yeah. Space is space. Space exists as a thing. Like, to say that it is empty, well, then what's it? You know, it's right. Like it's the ether. It's there. It's the distance between me and you isn't nothing.
Yeah.
It's the fabric on which we operate.
Yeah.
So to say that it's just a void is really uncreative and unimaginative.
It is. It really is. Yeah. And you could imagine.
And it's just because we don't know. We don't know what it is. We don't know how to define it. We don't know how to measure it. So it's like, well, it's just empty. We don't know. But I mean, clearly space-time. I mean, clearly gravity, or whatever gravity is what occurs when you stretch space-time by putting some massive object in it. So you put the Earth within this fabric. Well, then it stretches the fabric around the Earth, and it compresses that fabric because it's pushed it out. And so now all of that fabric that would have been where the Earth is now compressed into a much smaller space, and that's what we operate on, and that's why we see gravity. So clearly it is something. It is a fabric. It is this thing on which we operate. So just to say it's empty is, I don't get that. I don't get the whole gravity model and the whole empty space thing. It's just super boring and unimaginative.
It is. It's very lonely.
Yeah.
Okay, so if you scroll down, the hotel I made is so great. The hotel has a giant sketchbook with colored crayons, pencils. That's in the room, and a ukulele.
Right.
So I learned what's that ukulele song that everybody knows? Bruno Mars, 1, 2, 3.
Okay.
Call on Me.
I'm sure I know it.
You're right.
Yeah.
So I learned that when I arrived on the ukulele, and they had a sketch pad. So I thought for today I would draw a sketch of what the solar system really looks like.
All right, cool.
So in the upper left is the sun there, and then there are the filaments going. Jupiter's close to us, and then Jupiter has its own filaments going to its moons. You can see the 3 moons there around Jupiter, and there's the Earth off to the right. And it's receiving its filaments. It has its toroid shape, and it's feeding its moon with its own filaments. So if we had the eyes to see, this is what we would see.
And traveling through these filaments is just pure electricity, essentially, energy.
So what it is, it's plasma, which is this higher energy state of matter that everywhere through it are electric fields and magnetic fields.
But we can see plasma.
No, I mean
you can see lightning.
Well, right.
You can see the sun. You can see
So those are plasma that is in a state where it registers on our octave.
Yeah.
But there's dozens of other octaves of what plasma does that just don't register.
Okay.
We don't have the eyes for it. Yeah.
Interesting.
Yeah.
Yeah, I wasn't sure if the filament itself in your mind was plasma itself, or whether it was some electromagnetic field that plasma and other particles of energy
so this would be a good stopping point to address a little bit of that. Exactly as let's go back to the example of the arteries and veins. We know we have arteries and veins in us, and there's a cellular wall that defines the boundary of that tube. Okay. You can pass in, some things can pass in and out of that. A lot of things can't. When you come down to the capillary level, right? You remember, I used to love those movies in grade school. They had the movies of the blood cells going into the capillaries, individual blood cells going into individual capillaries. You still have the boundary. There is still a boundary, a boundary between the circulatory system and the blood cell. There is still a boundary between that and the what are sometimes called the somatic cells, the body cell, the muscle cell, whatever. And at the same time, the term for it is semi-permeable. There are certain things that do get through by design. So oxygen gets through. Oxygen has to be able to get through that boundary. Otherwise, your cells die. Carbon dioxide has to be able to go this way to pull that off. Nutrients have to be able to go from the blood into, so it's a semi-permeable membrane, as most membranes in the world are. Okay, it's the same is true in the solar system. There are these tubes, and they are just as defining or boundary making in their own world as our arteries and veins are in our cellular world. So if you're a piece of plasma flowing from the sun to Jupiter along one of those tubes, you're not leaving that tube. That is a boundary for you. And this was known about way back in the early part of the 1900s, studying plasma, is that plasma is really good at making boundaries. And they're semi-permeable in the sense that some things get through those boundaries, other things don't get through those boundaries.
You've seen those plasma balls that show up.
Yeah.
What are those called?
Plasma ball.
Yeah.
You talking about in the gift store or
No.
flying around?
Like out in, people see them in fields during lightning storms.
Yeah,
I
I was next to one for a while.
Okay. Yeah. So those seem to be conscious. Those seem to, like, people say, I know a guy, actually it was George Howard, and when he was a kid, he and his friends saw one that floated into a window that was open in their house and came into a room. But people see these things all the time, and they seem to have conscious qualities, and they seem to do things that are intentional and move in ways that are intentional. So what that says to me is that plasma itself has consciousness, and that maybe, or electromagnetic energy, or whatever the hell it is. And that's why I go back to that theory that we have trapped energy within our bodies, and we're the kind of the shell or the container for this energy, and that energy is life itself because it's conscious, like a plasma ball would be, or to your point, like the sun would be. A lightning bolt might have for a brief moment a level of awareness or consciousness.
Oh, I love it. I love it.
I wonder, like, and if the universe is alive and it has all these plasma filaments that are connecting it, then that's kind of the structure of the galaxy and the solar system, and the universe is like these plasma. It's almost like the veins within a human body or something, So I don't know, that when you were talking, it just sparked that thought that potentially, for me, that makes the most sense as to what life is. It's trapped energy, and it's, you get these ghost hunters going on shows with their electromagnetic field hunters, and they pop off in these old places. It's like that's what they're capturing, is the energy, the spirit. And I think all religious people all believe that it's the spirit that goes somewhere after life is over, and the spirit leaves the body and whatnot. So I didn't know, and then I'm thinking, okay, so you've got a sun, and the sun is then connected to other stars within the solar system in the electric universe theory by these bands of filaments. And so they're a part of a larger body that's connected and alive. And to your point, to your earlier point. So, could those filaments that connect solar system to solar system kind of be a way that things could travel or things could move from place to place, from long distances, one place to another? Could it be, I just, this Jeff Nusatelli episode that's coming out today, actually. So it'll be, I think, Ryan, we're releasing this episode a week from today. Is that right?
Tentatively, we can, a week from today.
Okay. So it'll be a week or two from today. So that's wild, because in the Jeff Nusatelli episode, he's got 100 witnesses. He's fully documented this sort of plasma-like structure, and actually about 24 of these plasma structures that approached Vandenberg military base that were seen by 100 or more people. And he's got written testimony. He's interviewed all these people. He's handed the actual daily logs into the FBI, into Aero to examine. Nobody's able to debunk him. He's testified in front of Congress. All these people are saying the same thing. If he's lying, he's going to jail. The FBI has these people's social security numbers and names. They've interviewed him. They've talked to him. They're all saying the same thing. So it happened. So it happened. And if that's the case, then a football field sized pizza box that looked like it was plasma approached an Air Force base and sat above these freaking missile silos that were shooting stuff into space when the Iraq War began for like 2 years. So that's like living conscious plasma in another vehicle, in another means, somewhere else. And so it all kind of starts to speak to this possibility, probability, whatever, that it's the plasma that's conscious, and it's the energy itself that's conscious, and maybe some advanced civilization, maybe future human, maybe past human, maybe whatever. It all seems to come from the ocean. The Nimitz incident, there was something that came up from the ocean. All these Vandenberg incidents, all the flap in New Jersey from a couple of years ago was coming off the ocean, and it's like these kind of weird plasma things. So I guess I don't, I wonder about the life itself. I wonder about this UFO phenomenon, about these filaments that are connecting solar systems, if that's a form for these vehicles to be able to travel on, any thoughts on any of that?
Yeah, I like it. I like that you're explaining it more detailed, because you mentioned it before. And now I think I'm more on board in the sense that, like, do I think a Han Solo Millennium Falcon steel object could be accelerated? No, I that's how I was thinking at first. But when you're phrasing it this way, well, what if your vehicle was made of plasma? Then I'm totally on board with that. Yes, if your vehicle itself had all the electromagnetic properties that we're talking about, you drop that onto one of those galactic filaments, boom.
You're there instantaneously almost, right?
Or I think, or at least it would be,
light,
it would be a speed level that would be just at a whole other.
I mean, if the filament itself, if the energy is moving at or near the speed of light, and then the vehicle, from its perspective, is traveling just with it, then it's moving at the speed of light. Or if it's traveling faster than relative to everything else, it's moving faster than the speed of light. So it's an interesting thing to kind of consider, as long as, if that's real, and it certainly seems to be real. Enough people have seen these orbs and these these plasma-based UAPs, that's really freaking conclusive at this point. It's certainly conclusive in my mind after this Jeff Nusatelli interview. If that's the case, then this filament could easily be the road, the galactic superhighway.
It certainly could be. It'd be like jumping on a river. Like, we want to get somewhere fast. Well, we'll jump on the river. That already gives us, whatever speed it gives us. Oh, and then we have ways of putting motors in. You could bias the electric field of your plasma ship that would then push you faster, right? So I think it's a very similar, and I think there's another element here to bring in, which is control of a system. You can give a system energy, so I can put a bunch of gasoline into a motor, and then that gives the power. Okay, but what's controlling that? How do I steer? How do I determine how much gasoline to burn? Right? There's the power, the raw potential, and then there's the control layer. And you see this everywhere. You see it everywhere. And so I think there's some element of that in all of this. There are signals coming from the sun to every planet that are connected with control, but not in the sense of like, I'm going to make you do stuff. It's like, oh, we need to like we got to tweak the ozone on the Earth because it's giving off too much whatever to Jupiter. I mean, I'm only half making that up. And that's the sort of thing that you would have to take care of. How are you going to tweak the ozone? I don't know. If you think chemically, then that's the whole thing about, oh, we got to stop using hairspray or whatever. And I know there's some truth to that. But in this paradigm, the sun would send some electrical signal that would tweak it and would go boop, and then no, a little more ozone. Oh, back it off, a little less ozone. So in addition to like a river that you can travel down and get somewhere fast, there's also this other attribute of how do you control a living system.
Okay, well, from here we got a couple of options. We can kind of plow through and finish up, or we can go get a bite to eat and kind of regroup and talk about how we want to finish out. So, do you have a preference? You needing a break yet, or how you feeling?
I do not need a break,
Okay.
but you I don't do this for a living. So, if you think this is a perfect time to take that little break,
Let's do it.
then we'll do it.
Yeah, let's do it. Yeah, we can regroup and kind of figure out a really strong way to finish out the pod.
Yeah.
All right, welcome back.
Are we recording?
Yeah, man, we're always recording in here.
We just leave it on.
Yep,
We just leave it
exactly.
on.
Yeah, so we were talking about light of life. We've got a couple more topics to cover. Light of life, time, and SAFIRE Project,
Yes.
and then we'll kind of wrap it up with those three big ones. So talk to me about light of life. That's one of your biggest videos out there on YouTube, right?
It's one of the most popular. It really is. It is just that. It is me looking into what is the role of light in life. I mean, you and I are kind of circling around this. What is life? Is electricity? Is that related to life, et cetera? Light is right in there, and light and electricity are inseparable, just as electricity and magnetism are inseparable. So these are very fundamental mysteries. Why do you always have together electricity, magnetism, and light? It's a very fundamental question. So if we could call up the Substack to get us rolling there. Okay. You can go down to the picture of what's his name again? Gurvich. Lots of consonants. Okay, this is an amazing experiment. He's looking at onions. He's looking at how do onion roots grow. And for some reason, which I don't know why, he thought, what's the role of light in stimulating onion root growth?
Okay.
Great question, right? And the upshot is that if you take a onion root which is growing, so roots have their growing phase. You put that next to an onion root that has not yet started its root growing phase, the one will stimulate the other one to get going.
Okay, faster than if there was nothing there. Okay.
Right. And then he started putting in barriers between the two to see are they talking to each other? What's the signal? What's the signal, right?
They actually are talking to each other.
And what he found the signal is it's ultraviolet light.
Okay.
So ultraviolet is one of those octaves that's beyond what we can see. It's faster frequency, higher vibration. So onion roots stimulate each other to all grow together through ultraviolet light. Now, how? I don't know. I don't know if anybody knows, but it is true.
Okay.
So go back to the document, the essay there. Okay. So does all light emit life? Sorry, does all life emit light? Maybe it works both ways. And basically the answer is yes. Every living thing that we have put a photo multiplying tube on is emitting light. So this wasn't, I mean, in the one sense, I think every poet and artist has known that forever. But in terms of like the progression of...
But it was new to science.
Yes. Again, scientists were surprised that all living things emit light.
Yeah.
And I'm not talking about just thermal radiation. Scientists have known about thermal radiation is everywhere. And that's this thing where, we call it heat. We call it heat. Like, the hot coffee radiates out heat energy and then cools down. So that's going on everywhere all the time.
Yep.
This is different. This is like different colors, different frequencies, different parts of the animal emitting at different amounts. And it's an amount of light emitted that is below what humans can see generally, not always. If you are someone who kind of trains yourself in dark environments, so if you're, say, a naturalist who's out studying nocturnal animals, right? So you're literally training yourself. Your eyes can start to see that the living things around you are emitting light.
Okay.
Right? So it's just right at that boundary. So let's see about a few examples here. Too fast. I had like a list of examples in this essay.
There was before we get to that, there was another study done that, I don't know if it was a study or if it was just proven scientifically or how it all went down, but that plants and trees communicate with each other through the mycelium that is underground, but they're communicating through the mycelium by sending electric currents. I forget exactly what it was. Ryan, you might be able to pull it up, but they're sending electrical signals basically from the roots through the mycelium to the root of another plant, and they're communicating with each other. And that's freaking wild.
Yeah.
That's crazy.
It is so wild. The level of interconnection. And for me, it hits at that.
Because now we know we also know they're breathing now. We can see that a plant we saw it breathing for the first time about a week ago is my
like,
I don't know if you saw that.
No, like what kind of cadence? Like once a day or once every minute or?
Like continuously breathing carbon dioxide and putting out oxygen. And so they're able to like physically see that now is cool. What I gleaned from the article. But there it is. So.
We've been, I think it's post-Darwin. We've been trained to think of living organisms as separate and competing for scarce resources, right?
Right.
So we want every organism wants.
Since the ego, we've all been separate and competing for resources.
That's an interesting connection.
Yeah.
And then you throw the British twist on it. You want to take over land and acquire mates.
Yeah.
Because that's the basics. You want land and you want mates.
Right.
Because that should explain most of life. And then when you hear stories like this, you're like, oh well, no. Clearly there is something. There is some bigger picture here that if we could zoom out, we wouldn't see them as separate competing organisms. We would see them as part of a larger fabric.
Right.
Which again, people have known for millennia.
Right. Yeah, no doubt. Okay, so that was a bit of a sidebar, but good conversation.
Yeah. So seeds, when it's springtime now up in Boston, and everybody's planting their seeds. And did you know that those seeds in the soil are, when they start to germinate, they start emitting light, and so they're all emitting light. And again, the horrible side of science that just says, well, that's for no reason. It just happens. It doesn't mean anything. It's not doing anything. And again, coming back to, that's not how nature works. Nature doesn't have elaborate systems that do nothing.
Right.
No. So this is somehow essential for seed growth. The fact that there's this light, right? We need to understand more about why. So scroll to the next little example.
So,
oh yes.
yeah,
Sorry.
go ahead.
Okay. So,
That's a whole other rabbit hole. I was just
all
about
right.
to take us.
And several times I referenced the Hamatsu photo detector. It's an industry standard. The Hamatsu Corporation makes these photo detectors, which can literally detect individual photons. Like, so these are like, So this is just crazy. You put someone in a room, dark room. You shave off the occipital cortex is back here. That's where your visual. That's the machinery for your vision system. That's not the right way to put it. When we see an image, there's a lot of steps between light hitting. There's a lot of steps that happen before
It's processed.
right, and then I see you in your amazing jogging outfit or whatever.
It's
Does it have a name? Is
phenomenal.
it just like just?
I think it's just I don't even know, to be honest with you. Yeah,
right. And the amount of processing is really surprising when you study it.
Edgar is his name.
Oh,
yes.
Edgar.
Yeah. So go ahead. Sorry. You know what I was thinking was, as you were talking about light and everything emitting this light, and then seeds emitting light. You're saying seeds are emitting this as well, right? So, I mean, could that be the basis of life? Is it like if similar to how if life was originally trapped in a single cell organism billions of years ago, and that single cell evolved to multicellular organism, and that continued to evolve into fish, and those fish got up on land and they evolved into humans. Well, that light that was captured in that single cell organism would be the life itself. It would be the basis of life. And then as it procreates and expands itself or does whatever it does to have its offspring, it would pass a little bit of that light off via whatever means to through a partner down to a child and or an offspring, and then that continues to grow on a biological living basis. But on a plant basis, could that same process be happening with the tree capturing the light through photosynthesis and dropping its seeds, which would contain light into the ground? And then that's what we're seeing. The seeds are giving off this light, but they have life within them to begin that growth process and capture more light.
Yeah.
And, through photosynthesis and grow.
So I think I'm getting more on your page here, because you talked about this a little bit before. So let me ask a question to see, is it possible to have non-living light?
Yeah.
Okay.
I think that once the light is captured within something, whether it's a cell or a human body or a plant or a ball of plasma or whatever the hell, that's when it becomes conscious. So it's not as if it's living or not living, it's just conscious or not conscious.
Yeah.
When the light is trapped, then that's when it has awareness of what's around it.
I like it.
Yeah.
And as the picture you're painting, I can see it. Again, we think in terms of chemistry, biochemistry, that the mother passes on chemicals.
Yeah.
But this is absolutely needs to be brought in. What you're saying, I think, is that there is light trapped is probably not the right word, in that mother, and that also is passed on.
Right.
And if the light were not passed on, it wouldn't work.
Right.
The process wouldn't work.
Right.
So that's in line with how you're.
Yeah. And maybe these ships that we're seeing, these plasma-based ships, maybe whoever created them or whatever created them, maybe some other plasma-based entity, maybe these ships themselves have trapped that light within the structure and created a conscious living entity. Maybe it's not nuts and bolts, but it's able to shift and change. And that's why on one incursion, it's a pizza box, and on the next incursion, it's a pyramid, and on the next one, it's a sphere, and on the, and it can kind of shape shift its form and its structure because it's just a single living plasma-based entity. I don't know. It's all, who knows? But I think it's time to start thinking a little bit differently about things.
Because I don't know if it's different really, but how I would phrase it is that the light can be the physical light. Here we're talking as if we know what light is.
Yeah, right. Yeah, we have no idea.
Whee! Okay, how I would phrase it is that the physical light, whatever the heck that is, can be a vehicle for consciousness or life. And so, the example you're giving, the ship, if that's it can be made that way. It can be made such that the operator's consciousness changes the ship, makes the ship do this, but light itself can exist without that.
Without being trapped and held in place
Right.
as a conscious thing. It can just continue along at the speed of light.
Yeah.
And just, at that point, it likely wouldn't have conscious identity. But as it would be trapped in the sun, potentially it is a conscious living organism, So.
Okay, next example.
Yeah.
Missions. Oh, right, the human body. Okay, so you put someone in a dark room. You put this Hamatsu photodetector on the occipital cortex there, and you take a baseline reading, and then you tell the person to imagine a bright light, and then you get all these photons being emitted from your occipital cortex.
Okay.
So you imagining light produces light. And you can say, well, that's just, neural activity in the brain. You haven't yes, no, but how does that? You haven't explained yet how that particular frequency of light is being emitted, So there's a lot of mysteries here. Our blood emits light. The immune response was found to be tied to the amount of light that the blood is emitting. That's great research. Someone should look into that. Our body emits light of different colors from different parts of it that varies over the time of year. So what was the example I gave here? The center of the body, the colors emitted around the center of the hand are mostly green, but they go to blue. I'll just read the sentence. The colors emitted are centered around green. This is the hand, but go from blue and yellow. That's a poorly written sentence, Michael. But go to blue and yellow, but light from the center of the palm is shifted slightly more towards the blue. Okay, just pointing out that, if we could see, you would see everybody, the center of everyone's palms would be blue. It's just so cool. Like, why? What is that? There is some point to that, right? Okay, blood is emitting light, scroll. Okay, so I'll just jump to the crazy one, which is at the bottom there, which let's scroll to the bottom, Ryan, see if we see if there's any image I want to point to. Oh, yay, no. Okay, I guess not. So just scroll a little bit to see if there's any, okay, so that's fine. Luc Montagnier, it's a French name, I'm not very good at pronouncing French names, one of the titans of genetic research. He died recently. I think he's credited with discovering the AIDS virus. Top tier, all his career. He wants to know how light is involved with genetics, with DNA, because there's a lot of mysterious things that DNA does, like it comes together into those coiled up chromosomes. But then it also can open up as needed. If you need to produce a certain protein, somehow your cell knows how to open up that part of your, enormous DNA to just express that, right? And then when the cells divide, all this dance happens with the chromosomes replicating millions and millions. It's just wild what happens. So he's asking, how is light involved in here? Okay, so it takes a little bit to explain it. You have, maybe I should draw the picture.
Okay, let's do it. We are set up for that.
Okay, Ryan. I'm activating drawing mode. Does a flippy flip? It does a flippy flip. All right. Here we have nothing. Beep. Here we have a vial that has some actual DNA from an actual creature. I forget what creature he used. And he does this crazy thing where he wraps a coil of wire around this and he drives it at different frequencies. So it might be pulsing back and forth, at 7.5 cycles per second, and he's exploring a lot. He went up to hundreds of cycles per second. Why would he want to do that? Well, over here, and he even did it, I think he did it. Oh, yeah, he did do it.
Cycles per second. So how does that work?
Yeah, so electricity, remember we were talking before about the Tesla coils and the transformers, and all of the electricity in our walls and our wall sockets, it's going back and forth.
Right.
It's just going back and forth. So that's what AC means, just going back and forth. Whereas a battery is a very different animal. It pushes electricity in one direction. So it's just different. It's a whole different way to do it.
So it's coming in the top and then it goes out back from the bottom back up to the top at 7.5 times per second.
Yep. It's going back and forth, back and forth.
Yep.
Then he has an antenna here. So he's listening. He's listening to the DNA. Let's see, how can I draw listening? I can't really draw. I'll make it like an eye. This is an antenna. If you stimulate anything, it'll give off its own natural frequencies. This is one of the principles. I was talking before about spectroscopy. If you stimulate molecules, they'll give off a certain type of light.
By stimulate, you mean?
You can excite them with a flame. You can excite them by shooting electricity through them.
Okay.
Yep. And he has an antenna that's listening to what's happening to the DNA. And then he takes that and he puts it through an amplifier and he broadcasts it to the lab across town. And the lab, I got to change pictures. Change. The lab across town. The lab across town. The lab across town has a vial that has amino acids in it, just the fragments of what you need. It has adenosine, guanine, cytosine, and GCTA. Those are the 4 nucleotides you need to make DNA. It's just a vial that has all the pieces that you need to make DNA. Over here, this one also has a coil around it. Whoops. And so he takes whatever comes out of this DNA and he broadcasts it into this vial that just has pieces of DNA.
Via
a radio. It's a radio system.
Radio wave.
Yes, this is all radio. A radio system. Antennas.
Okay.
So it takes a second, right, to take in the setup here. What do you think happens, Luke? Why did you publish this? Why is this so incredible? Because what happens over here is the same DNA forms that was in the first vial. It's the same. This is what he published. I haven't verified it, right? Same. So you can broadcast the signal of DNA to a vial full of pieces and it'll reform the same DNA.
Okay.
And radio frequencies
But
are...
you haven't verified this.
What's it?
Can we verify this? Should Ryan try to verify this real quick? That you said you have not verified it?
No, you can read Montagnier's papers.
Yeah.
I'm just saying I personally haven't verified it.
Oh, you haven't done it yourself.
Right.
I got you. But have they been peer reviewed and verified?
Well, this is part of the mysterious final chapters of Montagnier's life. What happened to this research? I don't know. This was right around the time that he started speaking up in the dark days of 2020 and 2021 saying, wait a minute, this is all wrong. And he got let go of his, he got kicked out, he got banished. His research, who knows what's happened to it. Fascinating end of a career.
Okay.
Yeah. So this is so outside of contemporary genetics. We are farting around with CRISPR technologies, and I don't even know the names of them anymore. You know, we are still doing biochemistry. We are putting chemical robots into nucleuses of cells that'll do chemistry and make chemical blah 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 blah. Nature is somehow doing this with light. Now, are you ready for the cherry on top?
Yep, let's do it.
The cherry on top. Dr. Clarage, what frequencies were best? Surely, since he was searching for frequencies,
Let me guess, 432 hertz.
here we are. We are right here, right? Florida. Here we are. Hello. The Earth has its own natural frequencies. Since the Earth is an electromagnetic being, electrical systems oscillate. The frequencies that the Earth oscillates at, these are rough numbers. They're known as the Schumann resonances. They've been known about for a long time. They, on the one hand, they are simply a result of the geometry of the Earth. The Earth is so big, the speed of light is whatever it is. That's going to define the frequencies that the electric body of the Earth oscillates at. But there's still a lot of mysteries about what are these Schumann resonances. This whole process that Montagnier worked on works best when he stimulates the original DNA at the Schumann resonances of the Earth.
Okay. Interesting.
Interesting.
Yeah. I was only familiar with the one Schumann resonance, the 7.5 hertz or so.
Yeah, there's I don't know, a dozen that are measurable.
And it's light that's bouncing between the surface of the Earth and the ionosphere and back and forth, and it's trapped within the Earth's biosphere itself. And so it's like all of this light, which light can have information written on it, has been in and around the Earth since the creation of the Earth, essentially. And so who knows if that's an explanation for why pyramids are built on one side of the Earth and on the other at the same time. Is this light information traveling? Is this how are psychedelics in part used and make the brain some antenna or something to capture the Schumann resonance information frequency on the that's traveling? Like, there's so many mysteries about the Schumann resonance and how it works and what it's contributing to, that it's really interesting to go down that rabbit hole. But
so remember what I was saying before about you can also use electricity to control a system?
yeah.
Like, how are you going to steer? How are you going to, accelerate and decelerate? If the natural frequencies of the electromagnetic body of the Earth are precisely the ones that forming and reforming of DNA is tuned to, then what I think it's a mystery why in evolution of life on Earth, things tend to stay constant, ecosystems tend to stay constant for tens of thousands of years or 100,000 years, and then very quickly they are turned into a new ecosystem. So this has been known about forever. What's his name? The great guy, Stephen Jay Gould, awesome paleontologist, top Darwinian evolutionist in the 70s in the whole world. He calls all of his colleagues to Harvard for a month-long conference because Darwinian evolution is broken. It doesn't actually explain the data. What they come up with is an acknowledgement, an admission, public admission that Darwinian evolution does not explain the historical record. I don't know why that public omission hasn't made it into any textbooks, but anyway. So what's the new theory? The new theory is called punctuated equilibrium, which is just what I said, that ecosystems, not animals, not individual animals, but ecosystems of animals tend to stay constant for tens of thousands or hundreds of thousands of years. And then very quickly, in geological time, it's a blink of an eye. You literally go from this like that. Very quickly, the whole ecosystem is reformed. So now we have all new types of plants, all new types of animals, and then that one continues for a while. So how does that happen? How does that change happen?
Cataclysms?
Or maybe the Earth and the Sun get together and say, okay, it's time for this one isn't working out so well, whatever. The temperature's going up. We need a new thing. Okay, let's do that. Okay, we're going to get rid of the saber-toothed tigers, and we're going to have coyotes, and we're going to get rid of those big. There's always big creatures that eat grass. We're going to get rid of those, and we're going to make new ones called cows. And I guess I'm just pointing out, I don't think we actually know how any of that happens. We have a story called Darwinian evolution, and it doesn't work. And the top biologists in the 70s admitted it doesn't work. And they created a new system which basically describes what we see, but it provides no mechanism for how it happens. So I think this has something to do with that. I think that what species show up on Earth is a bigger question than just what's happening on Earth, if that makes sense.
Yeah, for sure, for sure. Yep. Interesting, fascinating. Thank you for going down that rabbit hole. And you're a phenomenal artist, by the way. I should compliment your artistic ability, because that thing's not easy to draw on. So well done.
My first time.
One of the other topics we wanted to cover was time.
Time.
It's time to cover time.
Okay. So this is big topic switch. Time. Since Newton-ish, there's been a scientific conception of time, which is that it is something that just flows forward. I think Newton says justly and equitably, I think, that's translation from the Latin. Okay. Older knowledge, like I'm talking, 4,000 year ago Upanishads and 2,000 year ago Christian theologians recognized that time has different dimensions. So just like in space, we have a line, we have a plane. Oh, I forgot about point. Don't forget about the point. Point. So everybody knows this, so to speak, for space. We learn this in school and geometry, and it's actually concepts, experiences that we're very familiar with. Points, lines, planes, solids. Okay. There's an analogous framework in the world of time that we generally, our consciousness is attached to a moving point of time, and we call that the present moment. No one knows why it moves. Is there a speed at which the present moment moves?
Does it even move?
Does it even
is
move?
moving an assumption,
Exactly. Right?
Yeah.
So when you start to scratch a little bit at this whole thing, immediately you come up with questions like that.
Yeah,
and then
we always go to like the beginning and the end. Everything has a start and a finish. Everything has it's like this story, and it's partially based on the mind's obsession with past and future, and just and so it seemingly attempts to define the present moment. And nobody understands time at all,
No,
or what
at
it
all.
is, and whether or not it's moving, or whether or not, I mean, it's always the present moment. It's never been anything other than the present moment. So, is it moving? Are we constantly moving? Are we standing still? It seems like we're moving. I'm moving my hands.
Exactly, right.
They were here a second ago, but it's there's a lot of The Power of Now by Eckhart Tolle was one of the most game-changing, life-changing books that I've ever read.
I never read it.
Yeah,
Okay.
we'll
Well,
give
please
you a
bring it
copy.
in. Yeah,
Yeah.
as we're going.
Yeah, amazing. But go ahead. Sorry.
Okay, these older systems then also taught that there is such a thing as a line of time.
Because it's like gravity in a sense that we can measure it, but that doesn't make it real. Like we can measure gravity with a formula that Isaac Newton created, but that formula breaks down when you, like for Mercury, it doesn't work for Mercury because it just, it works for most objects and the formula itself, but if it doesn't work for everything, then it's probably not real. And so is gravity real, or is it just a product of space-time? Is it just an outcome? Are we measuring the outcome? It's kind of like time. Like, yeah, we can measure it. We can create clocks. But what is it that we're measuring?
What is it that we're measuring?
Yeah. So it's pretty interesting. It just seems to show that we don't have a full understanding of reality yet to really understand everything and how it all works together and all the dimensions and whatnot. Because sure, we can create a formula to measure all of these things, but that doesn't mean that we really understand them, So sorry to interrupt.
Okay, no,
but
I appreciate it.
Yeah.
There is such a thing as a line of time. And for each of us, our line of time is quite finite. It has at least in this world, in this earthly world, there's a point where conception happened, and there's a point where death happens, and then there's the life in between. And from this point of view that I'm trying to speak to, these older ideas of time, that entire line of your life exists. It exists as a whole. You could, if you had the ability, you could decide where you wanted to place your consciousness. We have this thing called memory, which is kind of lets us do that. Like I can remember last night that I went up that street, but then sometimes we have experiences where it's not that I'm remembering a year ago. Like I go there. It just appears, and I'm there in that event a year ago, poof, and then it goes away. That's different. That is actually your awareness moving from one point to another point, and then it pops back. So your awareness can pop back.
Are you saying like when I think back to an event from
No, it's not like thinking back. It's like you go back. Like sometimes smells, when you smell something, it can have that effect.
Gotcha.
Where you literally are back, you're 7 years old, you're on, it's fall, that's why you smell the leaves and the dirt, whatever. You go back, and then you come back here, and you're like, wow, what was that?
Once your mind realizes what's going on, then it just snaps you back.
It snaps you back, right? Because it wants to be in control.
Right, exactly.
Yeah, let's not have any of this time travel stuff. No, you're here now. It's 2026.
That's great.
And you have these things to do tomorrow, so
Right.
let's not,
Yeah. The mind freaks out when it loses control. That's why meditation's the best.
What kind do you?
I do spot meditation. I don't sit down for hours. I just meditate for 10 seconds here and there, 30 seconds, a minute,
nice.
and just
Wow.
my walk into the office, I cleared my mind, completely no mind, no thoughts, just, and it's just when I get overstimulated throughout the day because, big job or whatever, I'm taking breaks throughout the day. I try to just completely clear my mind of all thinking for just a few seconds, and that completely removes overstimulation and gets you back to the present moment. And in a meditative state, that's really the only time you experience present moment, because every other time your mind is in control and it's thinking about something in the future, it's thinking about something in the past. It's never in the present moment. So that's really keeping some portion of your awareness, of your consciousness, within your body is really the only way to stay present. And if you can keep all of it there and not think, actually not think, it's the healthiest thing that you can possibly do to experience the moment, to experience now. Yeah.
And it sounds like how you're describing it's the sort of thing that one could practice and get better
Absolutely.
at.
Yep.
So maybe the first year you're doing it, you're like, but then over time you're like, no, I can actually hold on. I'll be back in 3 minutes.
Exactly. Yeah. For at first, the first time you do it, the first time you experience that, and oftentimes it might be when you're looking at some, the Grand Canyon for the first time or something really beautiful. You just get lost in the moment. Or if you're riding a mountain bike down a tough trail or playing a video game even or whatever, your mind is completely blank and you're in the moment. It's captured you. And so a lot of times people can experience it like that. But yeah, outside of those things that kind of force you into the present moment, it's very difficult to get there if you don't realize that it's there and that it's always available. It's actually always the present moment. It's always available to grab a hold of and to experience and to be at peace of just being. And you can practice it for sure. Most of the time you'll experience it for just a quick second here and there. But if you can force yourself into that, most people have to do it through consciously sitting in a dark room, closing their eyes, getting into a pose and meditating, but you really, once you practice it enough, you don't really need all of that anymore. You can do it throughout the day as much as you want and just really get to a place of just chill, peace, calm. It's like, it's the absolute best thing. It's super Eastern. It hasn't made its way over here much, but it's been practiced by, you mentioned it, all the Christian mystics and all of the Buddha and all of the spiritual teachers throughout time have all spoken to this, and very, very powerful, and highly recommend trying it.
Yeah. I like it.
Yeah, the power now. We'll make sure the power of now is. It talks a lot about this, so we always give a guest a book. So that'll be the one that we'll give to.
I appreciate that.
Yeah, for sure. Yep.
That would be very cool.
Yeah, but sorry, sidebar there. But back to the present moment.
Okay, what exactly? we have a podcast to do. Matt, come on. Okay, back to now. Right, back to the present. We got stuff to do here. What would a plane of time be? So this is where there's 1,000 ways to describe it. So any one description is always going to be partial. Let's say like that this is, what day is today? It is Thursday. And it's 2026. But this is my whole life. This is conception to death. I wrote birth, but I mean conception, right? But there is a point right now that it's Thursday, 1:25:05. That point of time always exists. Dang it. Always exists. Always exists. It's always there is no place for it to go. It can't disappear. This whole part of the problem, I think, when you start to consider, like we were saying, does time move? If you think that time is moving, then where does the whole universe go every instant? Like the past is gone. Where did it go?
It's a former present moment.
You're talking an entire universe, and you're really telling me that the whole universe just disappears? Where's the past? It's nowhere. It's gone. So no, that can't. That's not any moment. Any now moment has to exist for always, forever. There's no place for it to go to. It always exists. And this is the word that we translate as eternity. So the Greek and the Latin have their versions of it. And something that lasts forever and ever, when you take an ancient Christian text and you translate it into Latin and then you translate it into English, you come up with this thing like, may you live forever and ever, or whatever. May you live for eternity. We are so poorly educated that we actually think that means that my future will go on forever, that I will have a line of time that will exist forever. It's never what it meant. It never meant that, ever. It always was related to this idea that any moment does exist forever. And so when the
present moment exists forever.
Well, I'm talking like when I said it was 125:05.
Yeah.
That is still, that me uttering those words is still going on.
It's written into history. It's written into the data, but the moment is now. And I'm not arguing. I'm just trying to understand.
Right. One of the analogies that's given is when I went from the hotel to here, we drove through the streets and we came up here. Those streets are still there. They can't disappear just because I'm not aware of them right now. They're still there. So that's an analogy. 125:05, where I pointed to the clock. I'm still pointing to the clock at 125:05. I will always be pointing to the clock at 125:05. That instance of reality will always exists.
Yeah, time's weird. The eternal. When I think about the great spiritual teachers and the great mystics and the gods, the Buddha, the Jesus, and what they were referring to when they talked about eternity, I feel like it's really being in that moment, but riding out that present moment as conscious awareness, regardless of whether you're in your body or not in your body, whether it's a future state and you've separated from your body or not. If you know that you are consciousness itself and energy cannot be created or destroyed, then that is everlasting, eternal life, and it doesn't go away once you separate from your body. And that is, I think that's a pretty profound. It really removes a lot of fear of death. It's not, nothing to. I'm not saying think about it because it removes fear, but I think it makes a lot of sense scientifically, from a mystical standpoint, from a theological standpoint, just in general, that's kind of what they were referring to, and what might actually be the reality as it relates to time itself, that it's just this eternal point of this dimension of time. It's eternally now. It's always been now. It will always ever be now in the future. It's always ever been now in the past. And we, as living beings in the present moment, are the creators. We are creating the earth. We are sculpting the earth in ways that we deem to be the best way. We're the stewards of our ecosystem. We are the creators. We're essentially gods right now as living beings. We are the gods and the creators of the earth because we're the ones that are connected to it and manifesting it, and either planting trees or cutting trees or building buildings or building streets or whatever it is that we're doing. We're the creators.
Yeah. We're
the creators, and we always ever will be. Whatever life itself is, that's alive at whatever moment it is a God, essentially. So,
is that related to? There's an idea that, someone might say to himself, why is my life the way it is? And the answer is, well, because you've made it that way. Is that along the same lines? Or
maybe, I don't know. Maybe, probably not so much. I mean, that sounds like a victim mentality to me. Yeah. It's probably overthinking. It's probably too much in the past. But anyway, we digress, because time gets so wacky, man.
It
to
does.
Talk about
it
it
does.
And to think about it is like, there's so much. It makes so much sense on the one hand, and it makes no sense on the other hand.
Right. Okay. And then the last dimension of time is all possibilities. This is something that the more I ponder it, I realize I've totally taken for granted possibilities. I've never thought about it, like how are possibilities created? How does that happen? How can there be options? Because if there's options, that means that there's like different lines of time you could go down. What space, to use the word loosely, what space do those different possible lines of time exist in? I'm saying for me more and more like, wow, I've really not thought this through.
Help me understand the question. Frame it in a different way, maybe.
So if you take a pool ball, you take a pool ball view of the universe. Everything obeys Newton's laws. Tell me where all the particles are and all of their velocities, and I will tell you the future. That whole line of thinking that really like ramped up around Laplace. He was so over the top. He actually said that. Tell me all the particles in the universe and all their velocities, and I will predict the future for you, right? So that is a way of thinking that that everything is simply determined by where everything is right now and all of its velocities.
But don't the gods get in the way? Don't they change the direction of everything's going, right? Us as humans, as animals, as whatever, all the living things that exist in the moment, aren't they? If a pool ball is going in a certain direction and some human comes and decides to grab it, that's not predetermined,
So I think this is part of the question I'm trying to get at. There is a type of thinking, especially in science. Actually, it showed up in religion too, predeterminism in religion. That's just that no, everything is predetermined. There's no, that's a way of thinking. It's maybe more prevalent than you are.
But it can't be predicted, right?
Well, this is just it. Of course, that the idea is that you could predict it. Anyway, it's a way of thinking that maybe you're not so subject to, right?
Yeah, I can't predict politicians what they're going to do tomorrow.
I know, right?
Or in the next 5 minutes.
And then there's this other way of thinking, which is no, there are possibilities. Okay. Meaning that the future is not determined.
Yeah.
Okay. But if you think that there really are possibilities, like you could turn left or right, then there is a future for you if you turned right, with all the events that will happen to you, all the thoughts you will have. It's the rest of your life, right? If you turn left, it's another story. Okay. How could there be How could there be those two, the option? How could there be possibilities? I guess part of what I'm proposing is
free will, right?
Possibilities have to exist somewhere. You can't have some, what's that line? The Beatles, nothing you can think that can't be thought, nothing you can sing that can't be sung. There's certain things that are not possible, and there's other things that are. How can they be possible? I don't know. I'm kind of saying the same thing over and over, so I should stop saying it. What I'm trying to relate it to this paradigm, this ancient paradigm of time, which is that there is a world that holds all your possibilities, which is pretty cool. There is some dimension of time or a world. There's a world that holds all of your possibilities.
Okay.
And the same is true of all creatures in the universe. So there is a world that holds all the possibilities for the earth. There is a world that holds all the possibilities for the sun. Okay. I want to, if we have time, I want to see if we can elaborate 2 reasons why this paradigm totally works.
Okay.
The first is, you brought it up earlier. How is it that when we try to talk about electrons, beep, going around that old nucleus, That's the old cartoon, nucleus in the center, electron going or orbiting around. And then quantum mechanics comes along and says, well, no, actually, you can't think about it
It's
that
just
way.
probabilities.
Boom.
Yeah. It's possibilities with probabilities.
Exactly.
Right.
It is just what you said.
Right.
Okay, that is an enormous change of worldview right there.
Totally.
And then you get into these arguments, which often are silly, but they're still arguments, which is, well, but where's the electron really? I mean, it's got to be somewhere, right? And this is part of the thing that
and quantum mechanics is like, no.
Exactly. It's like, no.
It's everywhere and nowhere, and it just has a probability of being somewhere.
Exactly. And I think if people were to take that to heart,
yes,
it could really change the way you see yourself and the world.
1,000%. It would end every argument. It would end anytime anyone has ever said, I'm right and you're wrong, it would completely shut that down. It would end every political debate. It would end every belief. It would end everything. Anything that we take to be true or false or right or wrong or whatever we realize is just a possibility with a probability, and that whatever this mental position is that I'm defending is just, whether it's Republicans are good or Democrats are bad or whatever it is, or on a specific issue that people might be arguing about, to say that I'm right and you're wrong is a fallacy. To say that we know everything about ancient history, for example, is a complete fallacy. I'm going to have two guys debate in a couple of weeks, and they're going to talk about how the pyramids were constructed. And one of them is going to say, I know how they were constructed because it was written down. And the other one's going to say, we have no idea how they were constructed and when they were constructed. And that second one is way closer to the truth, because all of those possible ways and times from which the pyramids were constructed are simply possibilities with probabilities assigned to them based on what we know. And all of them exist simultaneously at the same time as the truth until you observe it, until it's consciously observed.
Yeah.
And guess what? We're never going to consciously observe the past. We don't have enough information to put it together to really know the truth. So this is why open-mindedness is the only logical way of approaching life, because everything is, the Schrodinger's cat is both dead and alive until you observe it, until you go and look at it, and it's like, people don't get that. And it would literally completely just destroy the argumentative nature that exists within political system and anywhere that people get their ego and get defensive and get blaming and victim and attacking and defending and all of that bullshit. It would just all be gone if you could realize that things are just probabilities. It's just possible. It's just a possibility with a probability. It's mind-blowing what that could do to humanity if people actually began to recognize that quantum mechanics is baked in not just at the molecular level, it's baked into everything that happens everywhere.
Yes.
Everywhere.
Exactly.
Yeah.
So one of the things that shows up...
Sorry, I'm done.
No, I love it. I love everything you're saying. One of the things that quantum mechanics reveals in this story is that this relationship of me seeing the possibilities with probabilities happens when a larger world looks at a smaller world. Like as scientists, we didn't really prove what we were just saying until we looked at the smallest things. It was when we had instruments that could measure individual photons. Then, as scientists, we were able to prove exactly what we were saying. That photon does not have a position in space until you measure it. You cannot ask, well, yeah, but where was it really? Right? Okay. So that is one of the attributes of a larger world looking at a smaller world, is you can see its possibilities. I would propose that we can taste that ourselves, mostly with regard to like myself and another person. If I can find some way to rise up a little bit, then I can walk into the room, not as if I've known you for 20 years and I know what Matt's going to say. He always says the same thing. No, I can actually walk into the room and be like, who's this? I wonder what's going to happen today. And that is so liberating. That sets, I think it's along the lines you were saying, it just sets so much more freedom into the room, so much more liberating.
Yeah, for sure.
And if I can apply the same to myself, well, that's kingdom of heaven level shit, right?
Yep, no doubt.
Another way we will look at this. Ryan,
and by the way, what I'm saying is just a possibility with a probability as well.
I understand. I get it.
It could be totally off. It could be, but it's just a perspective. It's just, and I end up getting all heated and defending my perspective. It's the same thing. It's the same exact thing.
There's certain irony there. Yes,
it is. It's totally ironic, and it always humbles you to kind of to realize that. Yeah, for sure. So
yes.
Yep.
So Ryan, put up the time one, the time essay, and there's a certain Latin phrase in there. There we go. Okay, what we are looking at here is one of the most ancient teachings in Christianity, which I'm sure other ancient systems have. I'm not. Okay, so those of you who go into reactionary fits anytime anything religious is spoken about, you might want to plug your ears right now, because I'm not going to look at this religiously. I'm going to look at this teaching, but not in some religious way.
Well, this is more mystical Christian, right? I mean, there's a difference between, you mentioned you're Catholic, right? And but there's a difference between like Orthodox Catholicism and Christian mystic, and anytime you get into stuff like this, it tends to be like the mystical teachers of Christianity.
That's an okay way to put it. Yeah, definitely.
Yeah.
Okay, so
not that one is good and bad or right or wrong. It's just they're just a little bit different.
Yeah, it's a very complicated.
Yeah.
To tease that apart historically.
Yeah,
it's very, very. Okay, so what is the first part? Gloria Patri et Filio et Spiritui Sancto. I'm not going to delve into that, except to say that it is a statement of Trinity, that all manifestations happen with triples, because of triples. Any religion you look at, there's going to be three principles. It's, and sometimes religions are filled with it. Like everywhere you look, there's triples. When I went to Egypt in 2000, I saw it everywhere on the temples. It's not just, there's never just one thing. It's always three things related, and then another three things related, and another thing. So this whole concept of Trinity is so ancient. Okay, so that's what that first line is a statement of universal Trinity and everything. Now, what we're looking at now, the reason is the second line. Sicut erat in principio, et nunc, et semper, et in omnia saecula saeculorum. What is that saying? Sicut erat in principio.
Seems pretty obvious.
Does not mean as it was in the beginning, which is how it gets translated into English. Principio means much more like by design or in principle is a good, just translate it more literally, in principle, right? So this trinity of forces is in everything as a principle. Et nunc, that means right now. That means that point of time when I had the time drawings. Nunc means now. It means the present moment. So the Trinity exists everywhere in the universe. It's baked into the fabric. It's always everywhere. And it's right now. So it brings you right back to like right now. It's here. Et semper is that dimension of eternity that I was talking about. The everlastingness of moments. This mystery that you've brought up several times that now a lot of teachers talk about there's only one now, which is just, so that's what that semper, you could spend your whole life pondering what is that dimension of time, that everything we were just talking about. And then saecula saeculorum is something that it's almost impossible to translate into English because we've lost so much of this, but it means one of the meanings of it is that world of all possibilities, that everything is a possibility with probabilities. And that has been set up for us. That is the world we swim in. that there's possibilities. And in fact, there's possibilities like for your whole life. You could imagine a whole other line of time for you, and another line of time for you, and another line of time with you. And that's what that Saecula Saeculorum is. It's all of those possible versions of Matt. And the same is true of the Earth. There's all these different possibilities for how the Earth could live its life. There's all these different possibilities for how the sun can live its life. And all that together is that last part. That's what Saecula Saeculorum means. That's one of the meanings of it.
Okay.
So what I'm trying to point out is ancient Christianity had in it that time has different dimensions. And it is incumbent on us, because these are prayers. You're meant to say them and ponder them, right? Feel them, ponder them. It's incumbent on us to ponder this. That's one of the things that we should be doing, is pondering that there's these different dimensions of time.
Yep, for sure. Yeah, well said. All right, so
Okay.
that's time. We went deep on time.
We did.
Man.
I love time.
Yeah.
Let's hit some Sapphire, and then we'll be
Let's do it.
going the way out.
Let's do it. Perfect.
Okay, so the SAFIRE Project, I can't remember what pictures I put. Oh, yeah, I put some pictures in there for you, Ryan. It was a privately funded astrophysical experiment. The only one I know of. Because these days, if you're doing big astrophysics, you are working for a university or a government. Like, who does private, So incredibly lucky. This was like opportunity of a lifetime for all of us. There's Leighton working on, he's a master builder working on the chamber. There's me pondering some of what's going on in the chamber. You can see the anode right there is glowing. Just scroll a little bit more. There's Monty, the head of the project, with the chamber behind him. You can kind of get a feel for the size of the chamber by looking at what's behind him there. And then we'll just pause on this for a sec. So what we did was, if we're going to follow through the electric sun model in a laboratory, and we're going to see if we can replicate some of the behavior of the sun.
Okay. Cool.
Good theory, electric universe theory, good theory. Can you do any experiments, right? Very cool. Very cool. And I scroll down one. Just want to show some other. So there's another version of what the sun can look like in our laboratory. Is there one more, or is that it? That's it. Okay. I didn't want to fill with too many. You can look it up. Anybody who wants to see all kinds of images online about this. I'll just say that we worked for like 5 years really hard. We got great funding to make the project happen. And I feel it was an enormous success. So I'm just going to say 3 things that we learned. So one is, there's a mystery about the sun. Why does the temperature of the sun's atmosphere increase as you move away from the surface of the sun? We don't know anything else that behaves this way. If you had a thermonuclear bomb going off somewhere in space, wouldn't things get cooler as you moved away? Mm-hmm. Okay. And some people might say, no, we can explain it. But it's still, when you get down to details, like you get someone to actually try to explain, it doesn't work. Your theory always falls apart. So we didn't have any theory. We just set up the anode in the center, cathode around it, which is the electric universe model of the sun. And then we measured the temperature of the atmosphere through the chamber as you move away from the center. And the temperature went up as you moved away from the center. Boom. Basically you're done there. Go home. Woo, we won. Okay. Another thing we saw is the way that they're called coronal mass ejections or solar flares, these things that go flying off the sun. There's great videos of them.
CMEs.
The CMEs. I love them. But the details of how they happen, again, are mysterious. It's hard to explain why they do what they do, the way they do it.
Right.
And so similar with that, we just set it up. We had different types of atmosphere in there. I won't go into all that. And then you would watch the surface of the sun in the chamber. You would watch it. You could tell it was getting tension. And then you would get a coronal mass ejection off of the little anode.
Okay.
Super cool. And then the third thing is the elements. So we started making new elements in the chamber. I know some people still.
Was it what type of ejection? Were you getting like a plasma ejection?
Yes, a concentration, a blob of plasma would lift off and accelerate, which is what the suns do. They lift off and then accelerate.
Yeah, for sure. But where did it come from? Where did that excess plasma come from?
Oh, so go back to the one down. Yeah, that one right there. So you can see around the surface of that center sphere, there's.
Is that where you're saying it got hotter? Where the white light
Yes.
is around the sphere?
Yes.
Okay.
Yeah, exactly. That would build up, it would intensify, and it was wild that you could actually feel it. You could tell, and then it would break off and accelerate, away from the center.
Okay, but so what was the power? What was powering this? Like,
So this was a DC power supply. This
Okay.
particular set of experiments, yeah.
okay, just going up through that rod on the bottom.
Yeah.
And then what was the sphere?
That was various metals. We were experimenting with different metals. In terms of the overall behavior of the plasma system, it didn't make that much difference what metal we put in the middle. But in terms of the last thing I'm going to bring up, which is the elemental transmutation, we saw a lot depended. It varied a lot.
So do you think that the sun is a metallic object, or do you have any idea?
I have seen some evidence for that, which is wild. I haven't really looked at it in detail, but somebody did time overlaying the surface of the sun over different times, and it looks exactly like water flowing over rocks in a river. That the way that water flows over rocks in a river, and the water just keeps going by, and then there's always this hump right here. So if you do this with the surface of the sun, you will see similar things. It's like the surface of the sun is moving over something.
Okay.
I haven't really looked at it in detail.
Gotcha.
To me, it is a complete mystery what is inside the sun.
Yeah.
I don't even.
A lot of people now. Stefan Burns is one of the guys that I respect the most out there. That's like, I feel like one of the most legit, brilliant people that I've met in this podcasting space. And he's like, yeah, we don't know what the sun is. Like, we have no idea what the sun is.
No idea.
He's like, it's probably fusion, but we really have no idea. And that was kind of mind blowing to me.
Yeah.
To hear him say that. So, he's open to all different types of
Did he talk about
theories.
the mystery of sunspots?
A bit. Yep.
Yeah, like you look in the sunspot and you see nothing.
Yep.
Like, that's a little weird. And I've heard various explanations for why that's the case. And every explanation I'm hearing, I'm kind of like, okay, I think it's weird that, that we don't see anything.
Yeah.
Anyway. So the last part is the elemental transmutation, which we saw a lot of in our work, and other people do too. Science is at this strange point where most scientists still will tell you that it's not possible to make new elements inside of a chamber like that. Okay, but for decades now, people have been making new elements. So you're either kind of on that train or you're on the other train. And I have given up trying to convince anybody. I'm like, if you don't believe 7,000 published papers about people doing this under a variety of circumstances, then you're just fine. Don't believe that elemental transmutations are possible. Fine. I'm going this way because, and so the elements that we produced.
Both is a possibility with a probability, right?
Exactly.
Yeah.
And which one do you want to go down?
Yeah.
And the elements we produced were basically had the distribution of the elements in the Earth's crust and also the elements that you see in the interstellar medium, which, it wouldn't have to go that way. If you're mucking around with changing nuclei into other nuclei, who knows what you'll get? Because the theory for it is very, I don't know what word to use, naive, nascent. There's not much really good theory for how this happens, even though people have been doing it for decades. So I'm just saying, a priori, if I tell you I am changing the nuclei of various anodes there, what do you expect would come out the other end? Oh, well, what came out the other end is basically the distribution of elements you see in outer space around us, in those molecular clouds that I was talking about. Same distribution of elements.
Okay.
And also on the Earth's crust, pretty much the same distribution.
Wow.
That is so cool. So to me, I know that may not be a validation of, some people might not consider that as a validation that the electric sun is a viable hypothesis. To me, that is a huge validation that the electric sun is a viable hypothesis, because we're producing just what I said.
Oh, that's cool. That's
It is
cool.
very cool.
So,
And
go ahead.
I was going to say, in terms of like, is any of this accepted? Is this becoming accepted, by scientists? And when I started this journey in 2012, I read I just research hound. I would go into the library for days, right? It was so rare to find anybody talking about electricity on the sun. Occasionally you could find something. Fast forward 10 years later, 12 years later, there's a lot of papers talking about the flow of electricity on the sun. So those coronal loops, those arcs, yeah, people are publishing. Oh, that we can say there's 10 million amps flowing through that arc, right? So in 10 years, we've gone from, we don't talk about this, it is not publishable. We've gone to, So I think it kind of depends upon where you are on the spectrum as a solar physicist. You might be like, no, it's absurd. There can't be electricity on the sun. Here's why. You're probably an older person at that point. And then there's a whole new crop of people that are like, oh, of course there's electricity on the sun. It's obvious. How else would you get the magnetic fields if you can't get magnetic fields if you don't have, blah, 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 blah. So that's really exciting to me that there's that change that quickly.
Yeah,
In
very
terms
cool.
of the SAFIRE project, so we've continued. We are heading down commercialization in two areas which are related. One is the remediation of nuclear waste. So since we can change nuclei, we could take a nasty, like cesium-137, which is one of the nastiest things that comes out of and we can change it into benign daughter elements. So that has some real possibility. And then also when you do that, anytime you're splitting up big atoms, you get energy. It just comes out, right? So those two routes we're pursuing right now. If anybody wants to support us, you can look it up, SAFIRE Project. Aureon is the name of the company, Aureon. So that's where that's at.
Very cool.
Yeah.
Very cool. Yeah, I was going to ask you, that was going to be my question. Where's the SAFIRE Project now and what's happening next?
Yeah, just that.
Yeah, that's cool. That's cool.
Yeah, our next goal is prototype. In like 3 years, we want to have a thing in those metal sea containers, those big, we want a device in the sea container in some location doing what I just said, one of the two things I said.
Ah, very cool. Very
Yeah.
cool. Well, great, man. It's been a lot of fun chatting with you. Time flies in here for sure. It's like time's weird as we talked about, but what did we miss? Did we miss anything?
I think it's probably good.
Yeah. Yeah, we covered a lot.
We covered a lot.
Yeah.
We covered a lot.
Yep.
I kind of broke my rule of just try to say one or two things.
So is the electric universe a possibility with a probability, or is it 100% real?
Yeah. Great question. Yeah. Good question.
Yeah. Fair. It's been awesome to chat with you
So
today,
good.
man. Yeah.
I realized kind of halfway through that this is so wonderful, and I was kind of taking it for granted, like, oh yeah, this is what we do, right? And then it just kind of hit me, just like literally like 2 minutes ago, like, oh shit, this has been so incredible.
Cool.
This has been so like unusual, right?
Good.
Yeah.
Good. So you enjoyed the experience then,
Yeah,
the whole
very
thing.
much so.
Good. Awesome.
Very
When you
much
flying back today?
No, I gave myself a day to play.
Good for
down
you.
here.
Good for you.
and then I'm flying out tomorrow night.
Excellent. Well, enjoy your time. It's a
Yeah,
beautiful
thank you.
area. Any other guests do you think that you know of that I should think about exploring this topic with? The audience is screaming, and if the audience has ideas or comments on this, please shoot me a comment too.
Yeah.
But I know you're respected and established in the community.
Yeah. I'm sorry. To everyone I'm blanking on, I'm sorry. I'll let you know.
All good. Yeah, perfect. Awesome, man. That was a lot of fun. We'll
Thanks
wrap
so
with
much.
that.
Okay.
Yep. Great
See ya.
job. Thanks.